Okay, here we are. So, as per the stream title, I've decided that since I'm actively looking for a job, I'm going to be putting my prep work on Twitch and on YouTube. I'm going to be doing daily streams like this one where I'm solving challenges, for example, on LeetCode, or if at some point I feel like I need a break from LeetCode, I can hop over to coding games for like smaller challenges in a fun competitive setting. And miscellaneous other things, whatever just happens. Like, this is not going to be super structured really, except that it will be primarily interview prep. So yeah, without further ado, what I'm going to be doing is probably starting off with some easier problems on LeetCode and then working my way up to problems that are slightly more challenging, hopefully. A lot of the problems marked as hard on LeetCode generally require some specific knowledge to solve. Some of that knowledge I have, some of it I don't. Maybe we'll learn some of it along the way together, just through like reading about what the techniques are that are needed. At some point today, I do want to look at specifically some dynamic programming as well, because that's a technique that I tend to struggle with generally, so I'll be looking at that. And yeah, so the first problem I've selected here, I know it's going to be fairly straightforward, but I didn't read through the description yet. Finding the winner on a tic-tac-toe game. So tic-tac-toe is played by two players A and B on a 3x3 grid. The rules are players take turns. The first player A places an X, second player B always places an O. X and O are placed into empty squares, never on filled ones. The game ends when there are three of the same non-empty character filling any row, column, or diagonal. The game also ends if all squares are non-empty. No more moves can be played if the game's over, right? So you're given a 2D array with basically representing the state of the game. No. You're just given the moves. I see. You're just given the moves. The ith move will be played on grid row I, column I. Return the winner of the game if it exists, A or B, which would be X or O. In case the game ends in a draw, return draw. If there are still movements to play, return pending. You can assume that moves is valid. It follows the rules of tic-tac-toe. The grid is initially empty and A will play first. Okay, so pretty straightforward. I think all we have to do is... here is just take the moves that are passed in and fill a grid, and then we can look at it after all the moves are played. If there's any empty squares, we return pending. Otherwise, we check for consecutive X's or consecutive O's in the rows, columns, or diagonals. If one of those two cases exists, it actually is slightly more complicated than that. Wait, is it possible for there to be both consecutive X's and consecutive O's? In which case, whichever player won first actually wins. I don't think so, because that doesn't follow the rules of tic-tac-toe, right? As soon as a player wins, the game stops. So actually what I would need to do is, before I return pending, I do actually need to check if someone has won, because there could be empty squares if player A or player B has already won. But based on the description here, I don't think it's possible for there to be three in a row of X's and O's, and you then having to check like who finished first. So the primary languages I'm going to be using are C++, JavaScript, and Python. I did some solutions yesterday in C++ and JavaScript, so I'm going to start with Python 3 today. I just like to kind of mix up the language. I'm going to get rid of the type definitions because I'm not used to using type definitions in Python. And well, so I think for like harder challenges, it's probably going to be the case that I'll choose C++ most of the time, just because I'm fairly familiar with the standard library and some of the like built-in data structures that it offers. But for like easier problems or medium problems, it'll be a mix of JavaScript, Python 3, and C++, just depending on what I feel like doing. Okay, so the first thing that we would do is create a grid. So grid is going to be, how do we want to do this? 0, 1, and 2. What are the moves? Oh, the moves are just letters X's and O. Oh, no. Oh, the moves, I see. So you got to keep track of whose turn it is. The moves are just coordinates. So what we can do is we can use 0, 1, and 2. So we could do something like 0 equals empty, 1 equals X, and 2 equals O. I think that's what I'll do. So I'll have a grid 0 for I in range 3, for j in range 3. So this is a Python list comprehension that I haven't actually written in a while, so I'm going to take the liberty here to just print it, and let's see what we get. I think that that's right. Yeah. So we get all zeros in a 3x3 grid. So then the next step is just to go through the moves. So for can I do it this way? I assume I can. For ij in moves. For ij in moves. Print ij. Like I'm pretty sure that works in Python. It does. This could probably also be a tuple. I'm not sure if that's better in this case or not, but we'll do it that way. And we need to keep track of the turn. So turn is going to be equal to, I guess we can just have it be true and false. Turn is true, and we'll have true equals X's turn, and false equals Y's turn. So we go through the moves. So what we do then is grid ij equals 1 if turn else 2. Let's see. I think that will work. Oh, 1 if turn else 2, and then turn equals not turn. So we're going to flip it. So we get 1 0 0 0 1 0 2 2 1. So I can already tell just from looking at this that X has 1 on the main diagonal from the top left to the bottom right. So now we just need to write the code to also detect that that has indeed been the case. So let me just review the rules real quick. So I think all I need to do here is check for a winner. Then after I check for a winner, if any spaces are empty, I return. If there's no winner, then I check to see if there's any empty spaces. If there are, I return pending. If it's not, it's draw. And otherwise, the output is A or B. Yeah. And the output is just a string, A, B, or draw, or pending. Okay. I was just looking at the constraints there for a second. So let's just start by checking the columns. So for I in range 3, if I keep putting parentheses and semicolons in just because my brain's slightly in JavaScript C++ mode, which is, it's kind of why I want to try to incorporate more Python into this as well. So here's the plan. If grid, so actually I can check the rows and the columns at the same time. So if grid I 0, okay, this is actually really easy. So I can do if j in range 3. If grid, oh, you know what? It actually is, I think it'll just be quicker to write it this way. If grid I 0 equals x and grid I1 equals x and grid I2 equals x, then player A has 1. Same thing for wait, what am I doing? I renamed these to be 1s and 2s. So 1s means x. So in Python, I can do this, right? I can do that. If those are all equal, I think I can do that. Then we return A, and then we would do the same thing but checking for 2s, which is O's. Return B. And then I can actually, so that checks the rows. So I can check the columns simply by inverting these coordinates. If 0i, 1i, and 2i, right, I could do that. And then I could do the same thing for checking the columns for an O victory. So if all of those are 2, then the answer is B. So that checks the rows and the columns. Next we need to check the two diagonals. Probably easiest just to check them explicitly. So if grid 0, 0 equals grid 1, 1 equals grid 2, 2 equals 1, we return A. If they're all 2s, then we return B. Now, if we get to this point in the program and we haven't returned yet, then it's either a draw or it's pending. And the difference between those two cases is whether or not there are any empty squares in the grid. So I think I can just do for I in range 3, for j in range 3, if grid ij, if it's, so we'll just check to see if it's empty. Empty is 0 because I assigned 0 up here. So if it's 0, then we return pending. And then if we get to the bottom of that double for loop and we still haven't returned, then that means that the game is a draw. Let's see what happens if we run this on the... Okay, so we passed the first test case. Let's put the other test cases in as well. So there's that test case. Here's this test case. Let's run that. Okay, so I do have a bug that I need to track down. Test case 2 is wrong. Test case 2, I'm saying pending, but apparently it's actually a B victory. So what did I mess up here? I0, I1, I2, 0i, 1i, 2i. Those both return A. I0, I1, I2 for 2, 0i, 1i, 2i for 2 return B. Wait, so here's what I'm going to do. So let me just copy the test cases out and isolate the failing test case for a second. So I'll isolate the failing test case and let me print the grid so I can see what kind of victory it is. Right, so I say it's pending, but it should be a victory for O. So 2, oh, okay, interesting. So the victory for 2 is on, I did not check the diagonals properly. I didn't check one of the diagonals is what the problem is. So I checked the main diagonal. I did not check the 2, 0, 1, 1, 0, 2 diagonal. 2, 0, 1, 1, 0, 2, yeah. So I had missed some victory conditions there. Okay, so now it does indeed. So this is definitely not beautiful code, but for a question like this simple, I feel like it's fairly straightforward. I could probably find a prettier way to write this, but I expect now that if I test for all the test cases, they'll all be accepted. AB draw, and then submit, and it's accepted. Okay, cool. So that takes care of that one. Let's move on to a different problem. Let's see. I do want to do this at some point. Shortest word distance 2. This is a premium problem. 60% acceptance and medium. I kind of want to take a look at it. Yeah, let me save that one for next. Let me do another easy problem first. I'm trying to like warm my brain up. How about this one? We got another premium problem that's easy with 34% acceptance. So I'll take a look at this first. Okay, so a string can be abbreviated by replacing any number of non-adjacent, non-empty substrings with their lengths. The length should not have leading zeros. For example, a string such as substitution could be abbreviated as S10N sub 4 U4. I gotcha, yeah. 12, where you just replace the whole thing. So 3 I1. I see it, yeah. So you just have to have a letter. you have to have at least one letter in between each number that you put in. The following are not valid abbreviations. Yeah, because you gotta have a letter in the middle. S0, yeah, that's not valid. And then, okay, so given a word and an abbreviation, return whether the string matches the given abbreviation. That doesn't seem too bad. Yeah, that is fairly straightforward. You don't want to have just zeros in there. Does it say you can't just have zeros in there? Like, what if we had like S0U? Oh no, you can't. You can't do a non-empty substring because it would have to be an empty substring for it to become just a zero. And the length should not have leading zeros, which is a condition we'll just have to check for. Okay, so I think the move here is just to take the abbreviation, split it into its parts. Let me get rid of the type annotations. Just try to use Python for this one again. Is there a way to split a string based on a regex? You can do it in JavaScript. The problem is it drops. If you split it by the regex, it drops the thing that you, like for example, if we were to split on like sequences of numbers, which would work, you wouldn't get the sequences of numbers, you'd only get the letters. The other thing we can do is we can iterate just through the abbreviation one character at a time, and be building up like the parts. So we would have like parts equals empty list, and then for character C in the abbreviation. And what we would want to do is we would want to know what type of part we're starting with, which would just be a boolean. It's either a number part or a letter part. So we could have like part type equals how do I easily test for like digit, or yeah, Python is digit. There's probably a util for that, right? Yeah, that works. So just is digit abbreviation sub 0. So just is the first character a digit. So we want to do. So yeah, this will be fine. So basically, is part type will mean true for true equals digit, false equals letter. Then we will iterate through every character in the abbreviation, and we'll just do something like isdig equals isdigit C, and if dig is equal to part type. Part type is like the current part type, right? Current part type. And then we'll also just have current part is a empty string. So if the current character is here, we'll just change this to isDig. Wait, you know what? I should just be doing this. So if the current one matches the part type, then we're just adding it to the end of the current part. If it doesn't match, then we actually want to terminate the current part and start a new one. So we'll do parts.append current part, and we would do current part just equals C. Let's print the parts and see if that code is working. IsDigit is not defined. Oh, it's a method that you call on a string. So that's simple. I thought it was just a global function, but actually I need to do abbreviation 0.isDigit there, and I need to do c.isDigit here. And this one is current part type. So we got, okay, so we definitely got something that is not working. Oh, okay, I see what I messed up. So if the current part type matches, we're good. We just keep going. Otherwise, if the current part type changes, then we just have to flip the current part type. So current part type equals not current part type. Okay, so we got I, then 12, then IZ, then 4, and then we did not get N. And that's because after this loop finishes, we just need to take whatever the current part is and throw it on the end. So parts.append current part. And the current part type will have been, we'll still be able to use it. So after this loop terminates, we can basically treat current part type as last part type. We don't want that. We want to know what the first part type is. Or actually what we want is we just want this again. Because now the reason we want that again is because we're going to loop through the parts now. And this will tell us what the first part type is. Yeah. So this should work. Print parts. So now we should get what we would expect. I12, IZ4N. Okay, so that's a really good start. This is kind of unfortunate, but I need to take a quick bathroom break, and then we'll finish this problem. So I'm going to be right back for a second here. Okay, I'm back. I'm back. All right. So this is really good progress, just having the abbreviation split up into its parts. Let's review the instructions for a second. Okay, so I need to check to see if we have a valid abbreviation. It probably makes sense to do that before I check to see if the abbreviation matches the word. So first of all, you can't have two number parts in a row. Your number part cannot have a leading 0. And your number part cannot just be 0. Is that all I need to check? I think that's all I need to check. We'll find out soon enough. So let's just check all these things right now. So for part in parts. So actually, what we could check to see if it'd be slightly more efficient, but in this problem, it really doesn't make a difference. But it would be slightly faster to just first check to see if we have a valid abbreviation. Well, sorry, it would be more efficient to check that we have a valid abbreviation and also make sure that the abbreviation matches the word at the same time. So first of all, let's figure out what our starting part type is. Oh, you know what? Actually, what we want to do here is set this to -1. So current part type actually is going to represent the previous part type. So I'll rename it to previous part type. Or it's not really a rename. In this case, it's just creating a new variable. We still have access to our current part type up here, which I will reuse. So I'll reuse that. Current part type is going to equal part.isDigit. And this will work because I already split up the parts into like consecutive numbers and then consecutive letters. And so a part that has all consecutive numbers isDigit will return true for that. So we've got our current part type. What is that noise? Oh, some kind of hum coming from outside. I don't know if that's being picked up by the mic or not, but so for the current part type, so when we're on the first part, we can't check to see if we have the same part type as the previous part. So really what we want to do here is if previous part type is -1, then then it just becomes the current part type, and we don't have to check anything. Previous part type equals current part type. Otherwise, if we do have a previous part type, they need to not be the same. Yeah, okay, there might be a way to do this slightly differently, but let me just do it like this first. So the previous part type is not equal to -1, which means we're not at the first part anymore. We need to make sure that else if previous part type, if the previous part type equals the current part type, then we actually have an invalid abbreviation, and so we need to return false. Yeah. So this is simple. This is just return false right here. Otherwise, previous part type and current part type are different. So all we really need to do here is update the previous part type to be the current part type. Okay, yeah, so this actually is going to be the easier way to write this. So because I'm starting previous part type off at -1, and the way that the part types work is they're just true for digits and false for letters. All we really care about is whether or not the current part type equals the previous part type, because if the previous part type is -1, it's not possible for the current part type to equal that, because the current part type is going to be true or false. Python, hello. So previous part type. Otherwise, if they're not equal, then either we're just good, like they don't match, or we're at the first one. So we'll just do it that way. And so I think just with those lines of code, we've checked one of the conditions for an invalid abbreviation, which is that there has to at least be like one letter in between the numerical parts of this. The other thing we need to check is, so if the part type is a digit, so if the current part type is digit, so we can just do if current part type, because when that's true, that means that it's a digit. We actually just need to make sure that the first character is not a 0. That will handle both the case where that will handle the case where it's like just 0 by itself. It will also handle the case where we have leading zeros. So if current part type and part 0 equals the string 0, then we return false. Wait, so just to check, do they actually give us invalid abbreviations? That's actually unclear in the problem description, I think. Either way, our code's going to handle it, because I'm already going down this path. Oh, it says the length should not. So I feel like just because they said should not implies that we can get that as an input and we need to handle it. So I think we're probably doing it properly. Okay, cool. So here's what we want to do actually. The next thing that we're doing is, now that we've checked that we don't have like a repeated part type, we're just going to handle the two different cases separately. So if we have a current part type, we're going to handle for digital numeric parts, and then down here we'll have else, and this will handle just like a sequence of letters. So if we have a numerical part type, the first thing we'll do is we'll make sure that it doesn't start with 0. So hold on, in Python, I'm trying to remind myself, can I do this? Is that valid in Python? I think that you can do that in Ruby. I don't remember if you can do that in Python. Just in case you can't, let's rewrite it like that. Okay. So now that we know that there isn't a leading 0, let's actually just convert the part to an actual number, because up till now it's just been a string. So we convert it to be a number. And now what we want to do is because as we're iterating through the parts, what we want to be doing is also matching it against the word that we're given. So let's say that part is 5. We kind of want to like skip 5 characters within the word. So what we'll do is we'll have something like a current position. We'll just call it pause. Pause equals 0. Pause represents that we're at the 0th index. Pause represents the next index in the word that we want to validate is correct. So pause equals 0 means that as we're coming through the loop, whatever pause is, we're just gonna, that's the next character that we need to validate. Pause equals 0 represents that we're just starting at the beginning of the word. So I think all we need to do here is skip whatever the part says we need to skip. So if part is 3, we just take pause and we increase it by 3, and we skip those letters in the word. And since that's all we have to do, from what I can tell, I might as well just do int part right here. Okay, so now we're in the else case. So now we're talking about current part type equals false. That means that we have a letter sequence part. So if we have a letter sequence part, what we want to do is check. We need to start at pause, and then checking from pause and onwards, just make sure that the letters match. So so basically what we can do here is, I think we can do this. If part pause through pause plus the length of the part. I feel like that's right. If, hold on, if word equals, it is, yeah, so actually if that's not, so so this is like a slice in Python. So I'm basically starting at pause and going to pause plus the length of the part. And I want to make sure that that exactly matches whatever the part is. If that's not the case, we return false. Otherwise, in the other case, we know that we're still good. We have to keep going. We just have to increase pause by the length of the part. And then, let's see, we also have to handle a couple of cases. There's a couple of specific situations that we still need to handle. First of all, if pause has already exceeded the length of the word, then the abbreviation is too long and we need to return false. So if pause is greater than or equal to the length of the word, we can return false. Just like that. Also here, if pause plus the length of the part is greater than or equal to the length of the word, or that, we return false. So basically, if we still have some stuff left in the word to check, then this will be fine. But then the part could actually still be longer than the end of the word, and this should check that. Return false. Okay, so that might be all we need to do other than return true down here. Not 100% sure, but we're gonna find out. What happens if we run the code? Great. Why are we returning false? So why are we returning false? Here's an easy way to find out. At all the possible places that we can return false, we'll just print a number and figure out which of those is happening. Which of these return falses? Okay, so it's returning false because of this condition. Oh wait, this just needs to be greater than. If it's equal to, then we're good, right? Is that it? Okay, so that passes that test case. So let's comment out these prints and try the code on a few more test cases. Apple, oh, these have to be in quotes. Apple A2E, that doesn't work, so that should be false. There's other valid substitutions up here, so if you have substitution, if you have substitution, here, this is what I'm going to do, because it gives me a bunch of options there of valid abbreviations, so I'm just going to copy those in. So it could be S10N, right? It could also be sub4U4. I'm just copying in the test cases from the description here. Substitution, yeah. It could be 12. It could be SU3I1U2ON. That would also be a valid abbreviation of substitution. And it could also just be the word itself that's valid. Substitution. So that works too. And then let's also check these invalid cases as well. So substitution, substitution, substitution. So it cannot be S55N, so we would expect that to return false because of the consecutive fives. Oh, you know what's interesting is like this could be a valid abbreviation in a case where you have a word that starts with S, has 55 letters, and then ends with N, but it is not valid for this case of substitution. But I think that's fine. S010N doesn't work because it's got a leading 0, and S0 substitution. This also doesn't work because you can't have empty, you can't have 0 as part of the abbreviation. Okay, so we run this. Oh, okay, so this is a problem with the test case. Did I forget a set of quotes somewhere? What's going on here? What's wrong with my test cases? 1, 2, those two go together, those two go together, those two. Oh, really? The abbreviation has a max length 10. So this test case, that's funny. This test case is invalid both because it has a 0 as one of the parts of the abbreviation, but also because it has more than 10 characters in the abbreviation. So I'll just drop this last one and we should be okay. Oh, is there another example of that too? Oh. I should leave a comment on the description of this problem, because according to the problem description, substitution is a valid abbreviation of substitution, which per the rules of abbreviations defined by the problem is correct. But per the constraints down here, an abbreviation has to have less than or equal to 10 characters, and substitution has 12. So this is not a valid test case either. So we got true, false, true, 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 false, false. Yeah, okay, I think we're right. I think we're good. Submit. Okay. Wrong answer. It looks like I missed an edge case. Okay, so we're dealing with a part type true, which means a digit part. Oh, okay. We have another test case that we have to check here. So it can't have a leading 0, but it also can't be longer. It can't be more letters in the numeric part than what's left in the word. So, or pause plus. So I guess we do actually want to do, well, you know, this is fine, We'll just do pause plus equals, plus int of part is greater than the length of the word. Submit. Damn, there's a lot of cases I didn't check. All right, I apologize. It's supposed to be an easy problem, but I'm really fucking up the edge cases. High and 1. Oh, okay, this is easy. So if we finish processing all of the parts of the abbreviation, but pause is not equal to the length of the word, then it's also false. If pause is less than, we could just do if it's not equal to, right? If not pause is equal to the length of the word. It has to be exactly one past the last element. Then we get it. We get it. Delete the prints. Okay, we get it. It's a little bit of a tricky problem. I'm kind of glad that I did this one because it is like string processing. It's not like super complicated string processing, but you know, when you're doing those interviews, every once in a while they'll throw you something where you got to deal with like strings and indices and subarrays of strings, substrings of strings and stuff like that. So this is a good one. Let's get a couple more run times. $47, $37. Okay, so I had an outlier here, 63, but when you look at like 40, 47, and 37, we are faster than 80% of Python submissions, and we're using less memory than 30%. Which is fine. I'm fine with that. Let's see what some of the other people came up with. Let's look at the Python. Okay, this guy says his Python solution beats 100%. So let's see what this person did to get his to be so much faster. Oh, interesting. He's doing a two-pointer approach. So he's got I is iterating through word, and he's got J is iterating through abbreviation. And so he just has a while loop. As long as he's within the bounds of both the word and the abbreviation, he continues. And then this is where he does all of his like checks right here. Then if he gets to the end, he just makes sure that he's hit the only case where you want to return true is if you've consumed the whole word using I, and you've consumed the entire abbreviation using N. That's smart. Oh, that's smart. I like this solution a lot more than mine. Yeah, so as long as what's the current letter, so he's got I and J, which are I is consuming the word from left to right, J is consuming the abbreviation from left to right. So if word I equals abbreviation I, the only way that's possible is if it's a letter. If it is a letter, then you're good. They match and you just proceed to the next index. This is like a nice two-pointer approach. If this is not true, then the only other possibility is that you're starting a numeric section of the abbreviation, right? If statement is false, that means that either A, the letters don't match and therefore your abbreviation is invalid, or B, the other possibility is that you're starting a numeric segment of the abbreviation. So he just checks to see if the abbreviation is starting with 0, that part of the abbreviation anyway. If so, it's just false. Otherwise, he checks to see if it's numeric, right? It can be any other digit than 0, and we keep going. But so he handles what he's going to do here is he's going to write a while loop to handle the entire numeric section of the abbreviation before jumping back to doing validating one character at a time with this. So if the abbreviation at position J is not numeric, then that means that this failed because the letters didn't match, and so we jump down to this else and we return false. However, if abbreviation at J is numeric, then what he does is this while loop just figures out the entire length of the numeric piece of the abbreviation, and then he just increases I by that numeric part of the abbreviation converted to an integer, and then J is just K, right? Whatever the last value of K was, which is one index past the end of the numeric section of the abbreviation. This is a tricky solution. I don't think that I'd come up with this on the fly. I mean, clearly I didn't. But it is a really nice use of a two-pointer approach. Let's see here. I want to look at the comments. Someone says that it's not as fast as he says. Someone says they even have shorter code. Congrats, bro. Very proud of you for having that. How could the test case A01 be a valid test case in the question, it says? Yeah. Okay. Yeah, blah, 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 blah. Best solution by far. I agree. I agree. This is a really good solution. I'm gonna give this guy a thumbs up, and I'll even say really nice two-pointer approach, two-pointer-esque. That's awesome. I'm happy that someone came up with that. Yeah, descriptive variable names, whatever. This is a good approach. I do want to just comment. Let's see, description. Can I comment on the description? I wanted to complain. I wanted to file an official complaint about them saying that this is a valid abbreviation, and that them saying this is a valid abbreviation, because according to the constraints of the problem, the abbreviation needs to be less than or equal to 10 characters in length. And these are not even valid test cases because of the constraints. I would expect someone else to have noticed that, and yeah, whatever. It's fine. It's an easy problem. Like, I think if dumb stuff like that on like really hard problems, which tend to be more competitive, people would probably make a bigger deal out of it, but it's just an easy problem. So, all right. So moving on. I don't know what this problem is, but I selected it as the next one to look at. So let's see. Hopefully it's not too complicated. So we're looking at shortest word distance, number 2. Design a data structure that will be initialized with a string array, and then it should answer queries of the shortest distance between two different strings from the array. Implement the word distance class. Word distance, it gets initialized with an array of strings called the word dictionary. And then you get this shortest function, returns the shortest distance between word 1 and word 2 in the array words dict. Not a really great problem description. Let's take a look at the examples. So shortest.
You're trying to read.
Oh. My bad. I read this wrong. So this is usually the way that LeetCode handles showing you what the order of function calls is in the class that you write. So this is saying that the first element of the next array is what gets passed to the constructor. Then the next element is what gets passed to the first call of shortest. And then the next element after that is what gets passed to the second call of shortest. So we get initialized with
Please leave your name, number, and a message
with
after the
this.
tone.
So the word dictionary is practice makes perfect, coding makes. And then shortest distance from coding to practice.
Goodbye.
Huh? Oh, coding to practice. So a shortest distance from coding to practice is 1, 2, 3, because there's 2 words in between them. Shortest distance from makes to coding is 1, because you just go to the next. Okay. At most 5,000 calls will be made to shortest. Word 1 is not equal to word 2. Word 1 and word 2 are both in the dictionary. Word dict sub I consists of lowercase English letters. The max length of a word is 10, and the maximum total words that could be in the word dictionary is 30,000. So let's think about this, right? The obvious brute force solution is you get provided two words. Wait, so is this problem just pre-processing the word dictionary, calculating those minimum distances right at the beginning? Oh, wait. This is just a hash table, right? So we make a hash table that maps the words to the indices that they appear in the dictionary, because it doesn't say that all the words are unique. And that's why it's asking for the shortest distance, right? You could have the word practice again at the end here. That would be a valid word dictionary. And so what we would do is we create a hash table or a hash map that maps these strings to the indices that they appear in the word dictionary. So you'd have practice goes to 0, makes goes to 1, perfect goes to 2. If you had another practice at the end here, it would be practice goes to 0 and practice goes to 5. It would be 0 and 5. And then when you get your calls to the shortest function, you can look up the indices of both words and figure out which pair of indices are closest. Hold on a sec. Okay. So the question kind of boils down to, if you have two arrays of indices, what's a really efficient way to compare the elements of those two arrays and find the two elements, one from each array, that are closest to each other? What's the minimum absolute difference between two arrays? Now you could just use a double nested for loop, and you could compare every pair of elements, right? That's a thing that you can do. The question is that fast enough? Word 1 and word 2 are guaranteed to be in the words dictionary, which is nice. They're guaranteed to be different words, which is nice. 5,000 calls will be made to shortest. So the maximum amount of words you're going to have is 30,000. So they could be like 30,000 of like the same word, in which case you're going to have, and then like one or two other words like maybe mixed in there or something like that. If you have 30,000 of the same word, or actually let's think about it even differently. Let's say that you have 15,000 of word A, and you have 15,000 of word B. Then to use a double nested for loop to compare every pair of indices, that's going to be 15,000 times 15,000, which I think is going to be too slow. That is over 2 billion, which is too slow. So you cannot use a naive method to compare the indices of the two arrays to each other. You have to do something smarter than that. So something that jumps to mind is, how would sorting those two arrays help, right? So you iterate through the word dictionary, you create a, I'm going to use C++ for this problem. You iterate through the word dictionary, you create a map of the word to its indices, and then you sort that list of indices so that it goes from the smallest index to the largest index. Now, when you get your first call to the shortest function, you can look up those two arrays of indices, and all the smallest elements will be at the beginning, all the largest elements will be at the end. At that point, does it become like a 2-pointer? I've got like 2-pointer in my head because of that Python solution to the last problem that we looked at. So you look at the first two elements, the two smallest indices for both words, and you get you'll get an answer, right? A potential answer. Let's say that you get like 3 as the distance between those two. Now the question is then, do you want to look for which of those arrays do you want to move forwards in? Okay, so let's think about it this way. Let's just try to visualize this. So let's say we have a sorted array of indices 0, 4. I'm just throwing in random numbers 7, 13, 25, 101. I don't know. And then we have a second sorted array which is 2, 5, 8. We can't have it's not possible for there to be a repeat. 17, 55, 1003, right? We could have this situation. So we get a call to the shortest function for word A, which points to that, and then word B, which points to that. And I'm just going to rename this to B, A, and B, and I'm going to rename this to words. So now we're trying to figure out what is the smallest absolute difference between any two indices of these two arrays. Any two elements, rather. So obviously for 0 and 2, right, you're going to get 2. So you have a let's say that you're here, and then down here for B, you're here. So now we have a 2 is basically our candidate answer, right? Like we found the absolute difference between A and B's first element, which is 2, and that 2 is a candidate answer. Now we want to try to figure out, like, can we beat that? Can we reduce that to 1? And let's change the sample data here so that it actually is possible, right? So if I were to introduce a 16 here, we can see, I don't even need to. It already is that way. So if we look closely, there's 2. So 0 and 2 produces 2. 4 and 5 actually produce 1. So 1 is actually the correct solution to the problem. But our first candidate solution is 2. Now, what do we do here? If we move this pointer up, that actually changes our solution. That actually also produces 2, right? So we get another 2. Now, if we had not moved that pointer up, but we had moved this pointer up, right? If we had moved that pointer up instead, and this pointer stays here, like that, that changes our candidate answer to 5, which is considerably worse than what we already have, which is 2. So I'm trying to figure out, do we want to, it seems like we would want to move up this pointer instead of this pointer, because moving up this pointer gives us a worse answer. I don't even know if I'm on the right track at all here, by the way. I'm just brainstorming out loud. Let me just try to think if there's a completely different approach here. So there's an algorithm called Floyd-Warshall. Is that how you spell it? Floyd-Warshall. And this algorithm produces all the shortest paths between any two nodes in a graph. It's a directed weighted graph with positive or negative edge weights. No negative cycles. It essentially is like, it's a triply nested for loop. It runs in n cubed time. But what you get for that, n cubed is usually like, you look at n cubed and you're like, no, that's probably going to be too slow, right? But you only have to do this once. And if you have time up front to run this code, it'll tell you, it'll produce a two-dimensional array, giving you all of the shortest distances between any two nodes in a graph, which is similar to what we want here, although this is a medium problem, and I doubt that the solution to this medium problem is Floyd-Warshall. But we want to be able to answer these shortest queries as quickly as possible. How many calls to shortest? At most 5,000. That's still a lot, though. Oh yeah, remember that math I did earlier? This is actually 15,000 times 15,000 times 5,000, because they could give us the exact same query every time. Or, so if they gave us the exact same query, we can actually like potentially cache the results to previous queries and re-return them without having to recompute it. But if they gave us like slightly different queries, we could still be looking at a ridiculous amount of operations, effectively. So this is probably why this problem has a 30% acceptance rate, right? It probably has a 30% acceptance rate because people come in here and they implement, the first thing they try is like a sort of a brute force solution to it. It's either that or there's like edge cases that a lot of people miss the first time that they write a solution. I definitely feel like we should be able to get this one though. I'm trying to think if there's another data structure that could make these lookups easy. One such data structure is obviously if I just pre-compute all of the shortest distances using something similar to Floyd-Warshall. Then I can answer every query in constant time, right? I could just like return the distance between A and B, right? And then up here it would be build distance to the array and fill it with values. That would, so if I could do this, if I could do it this way, then as long as whatever code I have up here in the constructor doesn't take too long to run, this will be fine. This would get accepted. So let's just think about that for a second. How could I efficiently just compute all of these shortest paths as quickly as possible, right? So I would iterate through my list of words. I would process them one at a time, right? So I would have practice. And then what I would want to do is figure out what's the shortest distance from practice to all these other ones. And for the very first elements of the array, it's just going to be distance of 1 to makes, distance of 2 to perfect, distance of 3 to coding, distance of 4 to makes, except it wouldn't be distance of 4 to makes because we already know that the best distance to makes is 1, so we would just we would ignore that. Then we would come over here to makes, and we would want to know what is the minimum distance to everything else. Now we already know the minimum distance to practice is 1 because these edges are bidirectional, right? So if I know the minimum distance from practice to makes is 1, I also know that the minimum distance from makes to practice is 1. Then makes needs to know how far it is from perfect. Okay, so this runs in n squared time. What I have in my mind right now runs in n squared time relative to the number of words. It's n squared time, which is, it's the 15,000 times 15,000, which is that, which I think is still too slow. But we might be able to reuse information, right? Oh, we might not be able to, because what I was trying to think about is like, if we're trying to figure out the distance from makes to coding, now let's think about this slightly differently. Okay, so if we look at any pair of consecutive elements of this array, the minimum distance is always 1, right? We're looking at pairs. Now let's look at pairs that are a distance of 1 away. Like we have 1 element in between. We're looking at this, like we're looking at practice and perfect, and we're kind of ignoring makes. We know that distance is 2. Same thing for makes to coding. Same thing for perfect to makes. Is that still n squared time though, to calculate it that way? So like if we're trying to figure out the distance from makes to coding, we know that it's the distance of makes to if we're trying to find the distance from practice to coding, we know that it's the distance from makes to perfect plus 1, right? Because plus 2. I still feel like it's too slow. I still feel like that's n squared, and I think n squared on 30,000 elements is too slow. So am I missing like a crucial observation here? Let's not look at the hints. Let's look at the related topics, okay? Because there's no hints anyway on this one. But let's look at the related topics. Okay. So the related topics is actually 2 pointers, which is what I was doing here. Because 2 pointers is generally like a linear time operation, right? I would have this would be I, this would be J, right here. These are my candidate solutions. So I have I and J. I goes through the array once, J goes through the array once. Okay, let's try thinking about this differently. What if J started at the end, right? What if J was here? j was there, we know that the distance is 1003, right? So down here is our candidate solutions, our candidate answers. We got 1003 as the distance rather. Now, if I move I up to 4, so what I would then want to do is decide, do I move I up to 4 or do I move j down to 55? Moving j down to 55 significantly decreases, moving j down to 55 decreases the distance way more significantly than moving I up to 4. I think this is right. I think this is the answer. Like, is there any situation like where I would want to move I up to 4 rather than moving j down to 55? I always want to move the pointer that decreases the distance more. I think. So let's think about it this way. If I were to move I up to 4, I potentially lose out on, so let's say that this is a 1 right here instead of a 2. So if we put a 1 there as the first element of B instead of a 2, we can see just by looking at the input here that 0 to 1 generates a distance of 1, which is the answer to the question. Now, in the case of this data that I made up myself out of my head, 4 and 5 produce the same distance, and 7 and 8 produce the same distance. So really, any of those is fine. If my solution were to come up with any of those 3, it's fine. But let's say that the 4 and the 7 are not here, and let's say that the 5 and the 8 are not here. Now, the only way that I get my solution of 1 is with the 0 and the 1. I need to move these down. So if I were to move I up to 13, I actually discard the correct answer to the problem. I discard it. Whereas by moving j down from 1003 to 55, I still have it. So I think this is right, but I'm trying to figure out how to prove it. So by moving, is there a situation where moving j from 1003 to 55 discards the correct solution to the problem? So the way that I'm thinking about it is, as soon as I move either of these pointers, what I'm saying is any elements of the A array that are on the left side of I are not candidates for the correct solution anymore. Similarly, any elements of the B array that are on the right side of J are discarded as well. What my solution is trying to do is move I and J, like intelligently move them towards each other until they're sitting on the answer, right? That's what I'm trying to do. So if I move I up to 13, I'm already not going to get the correct answer. If I move J down to 55, I still can get the correct answer. But what I need to prove now is that that's always the case. So what I'm trying to prove is that 1003, just by looking at the current value at I and the current value at J, I can see that 1003 is never going to be part of the solution, because let's look at it this way. What if I had a 1002 over here? If I had a 1002 over there, and this was a 2, right? Let's look at it this way. so if I had a 2 here, now the solution is actually 1002, 1003. Not 0 and 2. But if I move J over to 55, because that's better than moving I up to 13. Yeah. So this is not quite right. I'm glad I didn't start to code that up yet. This is hard. This is hard. And I'm glad that I'm doing this one because this does seem like a reasonable question that you could get in an interview. Not gonna look at the solution. Companies. Apparently LinkedIn asked that 74 times in the last 6 months. Okay, so this doesn't work. So let's go back to having I and J start at the beginning, which gives us a candidate answer of 2. Now, how do we know which pointer to move up?
But there's a misunderstanding as to why.
If I move J up to 17, our candidate answer increases to 17, which is not good. We still have 2 as the best answer that we've seen so far. If I were to move I up to 13, we get a candidate answer of 11, right? 11 minus 2, 13 minus 2.
In Japan, we have the phrase,
So theoretically,
which means beginner's mind.
we would want to move the pointer up to here.
It is always ready for anything. It is open to everything. In the beginner's mind, there are many
Is that the solution?
possibilities.
Do I always move the pointer up to the one that gives us the best next candidate answer? I mean, I still have like 2. I'll always be keeping 2 in a variable as like the best we've seen so far. But then I move I up to, okay, so let's just do it. Let's visualize this. I move I up to 13. And I have a new candidate answer of 11. Is there a situation where I would have not wanted to move I up, right? So the way that this works is these are sorted from smallest to largest. That's something that I'll do in my constructor here. I'll pre-process these words so that I have the indices of each word sorted in ascending order. Now we look at the first 2 elements. These are the 2 smallest elements in both arrays. We get a candidate answer of 2, which is a really good candidate answer, but it's not the solution. We already know just by looking at it that the correct answer is 1, because there's a word A at index 100, 1002, there's a word B at index 1003. So they have a distance of 1. So by looking at the 2 smallest numbers, I get a candidate answer of 2. Then I want to figure out where to move I or J to. So I move I up to the next smallest, and J stays at 2. And what I'm trying to prove now is that by moving I up to the next smallest, it's not possible that I'm going to miss another value, another candidate answer that's better than 2, i.e. less than 2. And I don't think it's possible. But I'm trying to figure out how to prove it. I'm trying to figure out how to prove it verbally. Well, in my mind and then verbally. So we start off with the 2 smallest numbers. We get a candidate answer of 2. Then we can see that moving I up gives us a better solution than moving J up, even though the best answer we've seen so far is still 2. If we were to move J up, we would have 17. If we were to move I up, we have 11, right? Now, what if there was a 3 here? If there was a 3 here, we would want to move J up instead of I. Yeah. I think this is the answer. This is like this is one of the parts of this that I struggle with, is like, this seems like a working solution to me, but I don't actually want to go all in on it until I can explain why it always works. Which is, I think, is a good thing to always have in mind when you're doing problems like this, is you can get to the point where you have a really good feeling about a solution, but it generally, you don't want to code it up and like kind of commit to it until you have more than just a good feeling about it. You can actually explain why it's right. You know what I mean? That's what I'm trying to do here, and I think I'm close to being able to do that. So you move I up to the next smallest, or you move J up to the next smallest. The one you move depends on which of them gives you a better answer of the 2 possibilities of moving I up or moving J up. So when I move I up, when I move I up, I'm basically saying that 0 and 2 is the best possible thing that I can get for 0. Right? Like, I've looked at 0 and 2. I know that the distance between those is 2. And when I move I up, I'm saying that 0 cannot be paired with anything that's better than the 2 that we saw already. And that's right. That's correct. 0 cannot be paired up. Like, 0 paired with 17, 55, and 1003 is always going to be worse than the 0 and the 2, because of how these are sorted. So I move I up to 13. 2 paired with 0, we want to stay on the 2 because we could encounter a 3 here, right? This could have been a 3. And if that were a 3, I'm not going to have it be a 3, I'll have it stay as a 13. But if that were a 3 right there, we would improve our candidate answer to 1. So if this was a 3, after moving I up, we can actually see that our new candidate answer is 1. Like that. But let's go back. So the idea here is, I said this earlier, whenever I move one of these 2 pointers up, I'm saying that for all the values that I've already passed with this pointer, I already know what the best candidate answer is for all of those. And in the case of 0, we know it's 0 and 2. It's not possible to move I up and have elements of the B array that actually match better with this 0 than the 2 that we already looked at. Is that right? That's definitely right, isn't it? I don't really want to spend way too much more time on this problem. I think this is right. And I've tried really hard to prove it verbally, but my brain is drawing a blank on how to do so. Another way to think about it is when I is here, we have our candidate answer of 2. And we're trying to figure out whether to move I or J up. I almost had something there in my head. So 0 and 2, right? Candidate answer of 2. Then we want to figure out, is it possible that 0 has a better partner than 2, or 2 has a better partner than 0? And that's going to depend on... I might just code this up. I think it's going to be accepted, because I think this is right, but I'm just having a hard time putting words to why it's right, which is frustrating. I'm frustrated about that. I'm frustrated about that. So we're not doing this, we're not doing that. Actually, in this case, do I just move both of the pointers up, right? So I know that 0's best partner is 2. And similarly, I know that 2's best partner is 0. And the reason, or best so far. And the reason I know that is because when I look at the next elements, 0 matched with 17 gives us a distance of 17. 2 matched with 13 gives us a distance of 11. In both of those cases, it's better to have the 0 matched up with the 2 and the 2 to be matched up with the 0. So in this case, it might be actually best for I and J to both move up. Now, on the other hand, if this had been a 3, we can actually see that 2 matched with 3 is better than 2 matched with 0, and so we would only move up I. Alright, well, okay, here's what I'm going to do, okay? I've spent a lot of time in the analysis phase of solving this problem. This problem does have an official solution up here on the solution tab. So I'm going to code this up and I'm going to see if it gets accepted. Assuming it does, and I think it will, then we'll look in the solution tab, and the solution tab will probably have an explanation for why this is guaranteed to work. And then we'll read through that, and I'm going to absorb it into my brain and hopefully be able to apply those ideas again in the future. But I do think this works. I just don't know quite how to explain why. So starting the coding section of the problem, we're going to have an unordered map of string to unword map of string to int, and this is going to be indices. So basically for each word, we're going to store it in the map along with a vector event of the indices. So for int I equals 0, I is less than words dot size plus plus I. Word equals words I. Then the next step is if not indices dot count word. So basically if there's nothing in there for that, then indices word equals vector containing I, right? Seems logical. Otherwise, indices word dot pushback I. That'll work. Then once we get to the end, we now want to sort all those vectors. And I'm trying to remember how to iterate over a map. Oh, it's for auto iter in indices dot begin. Iter is not equal to indices dot end plus plus iterator. And then I think iter can be dereferenced into a first and a second. So all we need to do now is sort iter second dot begin, iter second dot end, right? I think that'll work. Let's log it just so that we know for sure. So we can see out iter first. And then for auto I in iter second see out I followed by a space, and then end the line here. Let's run that. Let's comment this just in case we want to come back to it. I'm missing. What am I missing? Oh, this should just be an equals sign. Yeah, this looks right. So that's our indices map that's been created. So now vector of int a, I'm gonna call it AI for no, I'll just call a indices, and I can make that a reference, right? A indices equals indices of A. Will that work? I think this works. Also, the indices needs to be a an instance variable. So we'll just do it this way. Okay. Okay, so that works. Okay, so now with 2 pointers, int I equals 0, j equals 0. While I is less than a indices dot size and j is less than b indices dot size we have a int answer, and since we're trying to find the shortest distance, we'll start this off at is it called numeric limits int : max? That sounds right. Let me just make sure that's right. Okay, yeah. So the first thing we do is we just update our answer. So answer equals the min of the current answer and a indices sub I minus a indices minus b indices sub j. That needs to be an absolute value. Can I just do this? Do I need to cast this as an int? C++ knowledge is a little rusty here. Absolute value of integer. Yeah, that works. Okay, so then the next step is we're just going to move either I or j up. I think, so when I was talking earlier, I think that there's a case where you can just move them both up, but I don't think that increases the speed of the answer significantly. So I'll just move them one up at a time for now. And so if we also have to make sure we don't go beyond the bounds. This is why I wanted to rename this to AI. I'm renaming this to AI. Sorry, BI for that one. It's too long to write, bro. It's too long to write. B indices, B indices. So if A basically if there's still a next element in A, and the absolute value of so if one of them is not in bounds, we can just increase the other one. Let's just take care of that first. If neither of them can be moved up, we break. And because I'm going to implement it that way, this can just be while true. I'll do while true, and then if I cannot be moved up and J cannot be moved up, so J is for bi dot size -1. So if neither of them can be moved up, then we just break out of the loop. Down here we're going to be returning the answer. Otherwise, we know that one of them can be moved up. So if only one of them can be moved up, then we just move that one up, right? So if AI can be moved up, then and BI cannot be moved up. There's probably a nicer way to write this, but this will work. If AI can be moved up, but J is greater than bi.size -2. Greater than or equal to bi.size -1. Yeah. So this means I can be moved up, so we just do ++i and we continue. And then we want to do the same thing for J. And then after all these if statements run, we know that both of them can be moved up. And then we just decide which one to move up. So if J is less than bi.size -1 and I is greater than or equal to ai.size -1, then we increase J and we continue. So now once we get to this line of code right here, we know that both I and J can still be moved up. So we'll handle that now. So we need to figure out which one to move up, and we'll just do that based on, we'll check what the distance is if we move them up like one at a time, and whichever one produces the minimum, that's the one that we move up. So if the absolute value of AI of I plus 1 minus bi sub j, if that's less than the absolute value of AI of I minus bi of j plus 1, then that means it's better to move I up. So here I'm going to write this really poorly just because I feel like it. We do ++i here, else we do ++j. Runtime error. What happened? Let's see if we at least got here. I imagine we did. All right, in C++, strings have to be double quotes. Okay, so we got there. call that here 0. Okay, something's wrong here. I messed something up. Let's do cout I and j. Okay, so 0, 0. Let's also cout the words A, B. So coding and practice, both of them just have 1. Here, let's move. So they both have 1, so we don't actually have to do much work for this test case. I just have an issue with like index overflow somewhere. So we cout I, j, and also the answer. Okay, so that since there's only one possibility, like practice and coding and practice both only appear once in the list of words, it's just going to be the difference of their indices, and so we do get 3. So the question is, why is the loop not terminating? And so it should actually terminate here. A less than size not 1, j less than bi dot size minus 1. So we should be breaking here. Why are we not? Because ai.size and bi.size should both be 1. Because practice and coding only appear once. So subtracting 1 from those gets us 0. What is wrong here? Because it's getting to here 1, which it should not. It should not get to here 1. I've done something stupid. Okay, I mean, I guess I just need to log the sizes. ai.size. I'm a little confused. 0011. So if I is less than 1 minus 1, so if basically if 0 is less than 0. Oh, I'm being dumb. This needs to be greater than or equal to. I just had my logic backwards. Okay. Delete the log there. Delete the log there. I don't think I have any other logs. Oh, I have here 1. Oh, hey, what's up, Stockton Wobalski? Are you trying to keep I and j roughly the same value to avoid calculating all possible differences with a double for loop? Not sure if that makes sense. No, it does make sense. If it's not breaking because you're breaking only. Yeah. Yeah, I just had my logic backwards. Thanks for pointing that out. Also, thanks for stopping by. So I started working on this problem, I think like an hour ago, and I've been brainstorming for a while. And yeah, I considered the double for loop, and I'm pretty sure that the double for loop is going to be too slow. And the reason I'm saying that is because the input, the number of words you get is 15,000, or sorry, 30,000. And so if we were doing n squared, you would get, if we had two different words, both 15,000 times each, it would be 15,000 times 15,000, which is 2.25 billion, and that's definitely too slow. So I was just assuming that they were going to need something a little bit faster than the n squared. And then the other hints that I got was I opened the related topics here in LeetCode, and it does say that 2 pointers is one of the related topics. And so that kind of confirmed a suspicion that I already had made, which is that you have to figure out the solution to this with 2 pointers. But yeah, thanks for coming in and seeing what I'm up to. All right, so we get accepted now for that test case, and something that's kind of shitty about this problem is that's the only test case they give. And so because I'm lazy and I'm not going to create any of my own, I'm just going to submit. Hey, we did it. We did it. I spent a really long time trying to convince myself that this logic is correct. I don't know if you were here, but I can show you kind of what my general approach is. So as you saw in the problem description, they give you the list of words. And so what I'm doing is I'm creating a hash map that maps the strings to the list of indices that come up that string has in the input. And so what you end up with is whenever a call comes through to shortest, I basically get, sorry. And then the last thing I do is I sort those, right? So I go through all the lists of indices and I sort them in ascending order. So when a call to shortest comes through, I have this sorted list of indices for A and the sorted list of indices for B. And then for a while I was trying to start off J at the other end. So I had J over here, and I was trying to move A forwards and J backwards, but that actually doesn't work for this problem. You have to start them off at the beginning. And so the logic ends up being you basically create like a candidate answer for whatever I and J point to, and then you move either I forward or you move J forward. And the way you decide which one to move forward is you look at I with the next element of the other array. So 0 and 17 would produce 17 as the distance, but then 2 and 13 would produce 11 as the distance. And so because moving I up gives you a better next candidate answer than moving J up, you end up moving I up. And then I spent a while trying to figure out how to prove to myself that that was going to work all the time. And I ended up not being able to do that, so I just coded it up anyway. And it does in fact work. So I'm pretty happy with that. Let me just delete my comments. I want to get a couple more run times, although I already saw that my my running time was pretty good. So it's like ranging between 40 milliseconds and 70 milliseconds. But more importantly, I like to see that I'm not too much slower than other solutions on the website. So yeah, that's it. That's the solution to shortest word distance 2. And what I like to do now is just kind of take a look at what they recommend in the solution tab. Use preprocessed sorted indices. Yeah, that's what we're doing. So what's approach 2, just out of curiosity? Is that the only approach? Oh, okay. Approach 1 is apparently the only approach. So move one step forward. I see. Yeah, yeah. So it is the same thing I'm doing. So they move forward the pointer that makes the next candidate answer less worse than the one that you have right now. And yeah, so the runtime of this is, well, it's linear for each query. And I think that this is probably a really long way of saying that exact same thing. Okay, cool. All right, so now I need to find a new problem. Let's see what they recommend as like the next problem. I don't know if I'm gonna do it for sure, but I'll just take a look. Okay, so there's the shortest word distance, which is a green problem. Then what we just did was shortest word distance 2. So I guess I could venture into shortest word distance 3 and take a look at what they change. And if it's significantly more complicated, I might not do it, but let's see. Given an array of strings, words dictionary, and 2 strings that already exist in the array, word 1 and word 2, return the shortest distance between these 2 words in the list. Note that word 1 and word 2 may be the same. It is guaranteed that they represent 2 individual words in the list. Oh, okay, so it's the exact same problem, except if they ask you for the shortest distance between 2 of the exact same word, then you have to find the 2 instances of that word that are closest together. So you could have like A equal, so let's go back to the indices array that I had before. So if the words are different, you end up with two completely different arrays. Like you could have like 7, 10, and then B you would have 1, 8, 13, I don't know, 27. So this is the case for if they ask you for the shortest distance between oh, you also don't get to pre-process. You also don't get to pre-process. Well, I guess you actually could. What you could do is you could pre-process and then store it in an instance variable so that like the next call to shortest word distance. Anyway, I don't think that makes a big difference. But then if they ask you for the shortest word distance between 2 of the same word, you basically end up with 2 copies of A, right? You would have like A equals that. And so you would just be looking for, it would actually be really simple, right? Like all you would need to do is look at the pairs of the array and keep track of which pair has the smallest difference. And I'm assuming that I would still want to pre-process. Yeah. I just want to, but I wouldn't need to pre-process all the indices in the words dict. I would only need to pre-process the indices for the 2 words that they give you. So let me just rename these to A and B. Rename this to words. And I'm going to now shamelessly copy some code from my previous solution, just because I don't feel like writing it again. Although writing it again might actually be better for like having the concept sink into my brain. So I is 0, I is less than words dot size. We get the current word. Word needs to be either word A or word B. So if word is not equal to A and word is not equal to B. I could be writing this differently, but this just enables me to reuse the code a little bit. So let me grab this. Okay, so I iterate through all the words. I skip words that are not the A and the B that they provide. I add the index to the map. Then I just go through the whole map and I sort all of the vectors that are in there. In the case of this problem, it will only be the two words. So then what I can do is I can do a vector of int. Well, actually what I can do is this. I can do if A equals B, we'll have a slightly different implementation as compared to if A is not equal B. So we'll have this. So if A is not equal to B, so there's going to be an int answer here, and then I'm going to return that once I have calculated it. So there'll obviously be lines of code in between there. And because I'm returning right there, I can just handle the case of A is not equal to B down here. And the case for A is not equal to B is literally just this, I think. Unless I'm missing something, which is possible. We can just test it real quick too. Okay, here we go. So the first test case, let's just run the code. Obviously this is not valid code. Okay, so for this test case, which is where the two words are different words, makes and coding, we do get the right answer because it's using this second solution here. But for the second example, let's see, use example test cases. Makes. For the second example, we're gonna get the wrong answer. We outputted 0. The answer is 3, and that's because we just need to implement this if statement. And so I think it's pretty easy. So we start that off with the max integer again. Int I is 0. I is going to be less than a dot length minus 1, because we're looking at pairs, so we want to skip the last element because I'm going to be doing I and I plus 1 plus I. Now it's really simple. Answer is going to be the minimum of the current answer and the absolute value of oh, this isn't, sorry, hold on a sec. This needs to be, okay, so I still need to grab this vector out of the map. So I'll do that. So AI dot length, and then it's going to be AI sub I minus AI sub I plus 1. Let's see if that works. Oh, because it's a vector, it needs to be dot size. Okay, so we get 1 and 3, which is the correct answer for the sample data. Once again, I'm going to not make more cases. I'm just going to submit. Okay, that was kind of dumb. I don't know why they created a level 3 of that problem, and it was basically the same thing with like one extra tiny for loop checking a really simple algorithm, just like, you know, comparing the consecutive pairs of an array. So anyway, we get that one as well. Let me delete this. Let's run it a few more times. Yeah, like, there's not even a solution for this one, and it's because they know that it's basically the solution to the last problem with one extra like simple for loop in it. So submit. I just kind of want to see what the range of my times is. Yeah, the timing is not very consistent, but I'm happy with that solution. Let's just look at the discussion. Interesting. And maybe there is, I guess there is a slightly more like compact solution to this problem. So that they start the distance off at int maxed. They have I1 starting off at the distance and I2 starting off at the negative distance. Then they go through all the words. Interesting. That's fascinating. Oh, wait a minute. Okay, so if words I is the first word, then we update I1. If words I is the second word, then if we are looking at the same word, I1 equals I2, otherwise just I2 equals I. And then the solution distance is the minimum of the current distance and then the absolute value of index 1 and index 2. Oh, does this work for the first problem as well, the last one? Seems to be pretty similar to previous problem, but nice job reusing a working solution. Yeah, thanks, man. Appreciate it. I kind of want to move on to something a little different, so I'm gonna not spend time trying to understand what's going on there. Instead, let's go back to what was the, I wanted to see what the next recommended problem was. Like, I wanted to see if there's a shortest word distance for, and there isn't, so let's just go back to the problem list and see what else is there. Sort by frequency. Sum of total strength of wizards. 24% acceptance and hard. Probably won't be able to do that one. Let's try to look for something more reasonable. Total appeal of a string. I kind of want to do a medium problem. I don't know if my brain is ready for hard right now. Background. Yeah, I have a CS degree, and I got my CS degree in 2016, and I've been working in the industry basically since then. So yeah, for like the last 6 or so years. I've gone through this grind before. So if I go to my LeetCode profile, you can see there's not a whole lot going on here. But then if I change it to 2020, you can see I had a 5-month span where I was grinding LeetCode. So I'm like pretty familiar with a lot of these concepts, but a lot of it I need to review. So here in like May through September of 2020, I was grinding a lot of LeetCode, and that was because I was preparing for job interviews at Google. And I ended up getting that job, and so I worked there for like the last 1.5 years, and I quit my job like a month and a half ago, like maybe 2 months ago, and I just kind of wanted to not be employed for a while. And I'm sure that there's a lot of people on the planet who could probably sympathize with that feeling. I just want to not be employed for a while. So I quit, and it's been great in many ways, but in other ways not. So now I'm back in the grind. I'm LeetCoding until I land another job. So I've got some companies in mind that I want to interview with, but before I do that, I know that like a lot of these concepts, I just need to refresh my memory. So yeah, that's what I'm doing. How about you? Are you like in a CS degree right now? Are you working in the industry? Are you preparing for jobs? What brings you to a LeetCoding stream? That's what I'm curious about. Feel free to let me know. It's kind of unfortunate, like, this is what you need to do if you want to get these jobs in the tech industry. Like, there's no other way other than just grinding these problems out, knowing how to solve them, being able to recognize, like, by looking at a problem, specific techniques that it might need. Like two pointers, obviously a very important technique. Similarly, dynamic programming is also very important. Sliding window, very important. Definitely learn those. You know, being able to do some graph theory, BFS, DFS, like that. I'm just trying to review like all that stuff. Didn't I have a problem picked out? I guess I'll just pick out a new problem. Kill process. This doesn't look too intimidating. It's a premium problem, so I'll try it because of that. 67% acceptance rate, medium difficulty. So let's just go take a look at what that is. Math degree, worked as a software engineer for 5 years before quitting and traveling for a while. Okay, so we did something similar. We worked for a while and then we quit. I didn't do too much traveling. I kind of wish I had done more. Would like to get a real software job rather than a customer support role like I had before, but the lack of a proper CS degree is limiting. Yeah, it's annoying how like a lot of the like really big tech companies just put that in the requirements. But like, look, in my opinion, the most important thing is like knowing how to do the job. And if you have to start off at like a lesser company than say something in like Fang or Mang or whatever it's called now, you just do that to get the experience on your resume. And then at some point, like once you have the experience on your resume, those companies start to care less about the CS degree and more about just what your experience is and whether or not you can do this stuff. So, yeah, I would say start grinding out these problems as early as possible. You know, there's a lot of great YouTube videos out there that explain the concepts like dynamic programming. Actually, that reminds me of something that I did want to do. So I noticed yesterday when I was browsing LeetCode that they have this ultimate DP study plan for dynamic programming. And I kind of want to go through this because dynamic programming is one of the areas I struggle with. Oh, that's cool. Look, it's like an actual like plan. 2 to 3 problems a day for 21 days. 2 to 3 problems a day for 21 days. Okay, let's start. I'm just going to try this out. Start dynamic programming 1. So Fibonacci number I'm not going to do because I know that. Let's see what this is. The Tribonacci sequence. Oh, this is easy. This might not be worth doing, but let's take a look anyway. The Tribonacci sequence T sub n is defined as follows. T0 is 0, T1 is 1, T2 is 1, T2, yeah, and then Tn plus 3 is T of n plus T of n plus 1 plus T of n plus 2. I see, for n is greater than 0. So it's basically the same. I'm not really interested in doing that. So here's what I'm gonna do. I'm actually gonna skip to dynamic programming level 2. Wait, can I exit this study plan? Back to study plan. Oh, did they not let you quit once you start? Like I want to leave this one and jump to level 2 of it. How do I get back to the ultimate DP study plan? LeetCode ultimate DP study plan. Okay, yeah, so this is kind of dumb, but it looks like I'm locked into level 1 now. Should I just do it? Let me just do the daily... I'll just do these 2 daily problems. I don't think they're going to be particularly challenging. So I don't think I'm going to worry too much about like the super low level efficiency of this. But, like, we create an unordered map of int to int f. Then they want the Fibonacci number for n. So we need to keep track of, oh, this needs to be moved up. This needs to be moved up here. What's the maximum value for n they would possibly give? 30. So I'm going to make a constructor. And I'm just going to compute those ahead of time and then just like return f of n right here. And then this will just be, I'll just have this be a vector of int. Is that how you do that in C++? So f dot pushback zero f dot pushback 1 for int I equals 2, I is less than, I don't know, like 31, because the max they'll ask is 30, right? Plus I. So this is not really dynamic programming, but it kind of is. People like to use the Fibonacci question as like an intro to dynamic programming, which it is a good introduction to it. But what I would do now is just f dot pushback f of I minus 1 plus f of I minus 2. Is that right? Okay. Also, it seems that on April 15th of 2021, I solved this problem, also in 0 milliseconds. Oh, but I used more memory this time. Okay, whatever. So we did that one. Let's see, does the problem update? Okay, we got that. So now Tribonacci. The Tribonacci sequence, I mean, it's just the same, right? You just put the first 3 values in, and then you just do a loop. I don't think I'm going to bother with a constructor this time. Vector of int t for Tribonacci, t dot pushback 0. This just kind of feels like a waste of time, but maybe tomorrow the daily dynamic programming questions will be better. 0, 1, 1 for int I equals 3, I is less than 38, plus I, t dot pushback, t of I minus 3 plus t of I minus 2 plus t of I minus 1. Because that runs pretty fast, so I don't really care. I just want to finish this. Return t of n. One way to optimize this with space, I'm not sure if you were aware, it's not really a huge deal, but you don't need to keep track of like all the numbers that you've calculated so far. In the case of Fibonacci, you just need to keep track of the last 2. And in the case of Tribonacci, which I literally is a word that I just learned now, you would just need to keep track of 3. So you could just have like 3 ints here, like A, B, and C, and they just represent the last 3 and then in your loop you just update those. So you don't need to have a vector. Okay. So I did my dynamic programming studying for the day. Yeah, these already look better right here. Climbing stairs and min cost to climb stairs. So you can probably tell from the stream title that I'm planning on doing this every day for a while. So tomorrow I'll definitely come back and do day 2 of dynamic programming. Okay, let's take a look at this. You have n processes forming a rooted tree structure. You're given 2 integer arrays, PID and PPID, where PID is the ID of the ith process and PPID is the ID of the ith process's parent process. Okay, so this is a tree problem. Each process has only one parent process but may have multiple children processes. Only one process has PPID of I equals 0, which means this process has no parent process. It's the root of the tree. When a process is killed, all of its children processes will also be killed. Given an integer kill representing the ID of a process you want to kill, return a list of the IDs of the processes that will be killed. You may return the answer in any order. That seems fairly straightforward. So when they give us a process ID, we just start at that node and we traverse the subtree that's rooted at that node, and we collect a list of all the IDs of the children, and we return that. So if I look at the input here, process IDs are 1, 3, 10, and 5, which is these 4 processes. The parent process ID is 3053, and so the 0 here implies that the 3 is the root of the tree. So what's interesting about this is they're kind of, the problem seems to be you have to like invert the input a little bit, because the input gives you like each process along with an edge to the process's parent node. But if we want to traverse the tree downwards from a node, we need to know, instead of what the parents of each node are, we want to know what the children of each node are. And then it becomes a simple like DFS through all the children. Also, I don't know if you're still chilling, but yeah, you said you'd like to get a real software job rather than a customer support role. And I was just curious, like, what's your, like, what are you trying so far? Like, do you have a study plan? Are you doing LeetCode as well? Because that's what I would recommend. As you can see, I mean, that's literally what I'm doing. So, but do you have like a study guide that you're following, or like a course or anything like that? There's a lot of great resources out there. I don't know if you've heard of Algo Expert. Let's see, algoexpert.io. I think I might still have this. Do I still own it? Oh no, I don't. Like my license for this expired. This is actually a paid resource. But when I was preparing for my last set of interviews, in addition to grinding out LeetCode, not enough study streams, what's up? In addition to grinding out LeetCode, I also bought the license to this, and I can tell you it's like 100% worth the money. This course, they've got algorithms, they've got systems design, they've got front end and ML. Depending on what you want, you probably just want to look at either just the algorithms part or algorithms and systems. And like, I can guarantee you, like, I don't remember how much this costs. Let's see. Where's the pricing? Oh, here we go, purchase. So Algo Expert is $83 for a year. The full tech interview bundle, which gives you Algo Expert and Systems Expert, is $132. And like, it is expensive, but it's not expensive if you think about the fact that this will help you get potentially like a job, like a top job, you know what I mean? Where you're making like competitive salaries for the tech industry. So I might actually end up like rebuying either the Algo Expert bundle or the whole tech interview bundle soon, like maybe we even within the next week or two, because this is some of the best stuff out there. They have a lot of coding challenges like LeetCode, and for every single challenge they have a video explanation that like walks you through the solution and like how to get to the solution, you know. This is really good. Like every time one of my friends asks me like, hey, what should I do to prepare for tech interviews, I always say, bro, go get Algo Expert and do LeetCode. Those are my top 2 resources, and it's definitely worth the money. So Stockton, you said just doing a bit of LeetCode and reading 2 textbooks on algorithms and networking. Since I didn't get much in depth with those topics in the few CS courses I took, I don't have a formal plan though. Yeah, LeetCode sounds great. Yeah, the textbooks. Honestly, like trying to read textbooks on algorithms is really hard. I mean, maybe they have better textbooks now than back when I was reading textbooks on algorithms. But I find that textbooks on algorithms are not as it depends on what kind of learner you are too. Like maybe there's some people out there that can learn really easily from textbooks, but I like watching videos with explanations and stuff like that. Snubs Codes, are you just doing random questions right now? Basically, yeah, I'm basically doing random questions. I'm planning for this to be a daily stream where I do preparation for technical interviews. So right now I'm just doing random questions. So far today, I think I've solved 4 or 5. I started with a really easy problem, find the winner on a tic-tac-toe game. That was an easy problem, as you can probably imagine, if you're into this stuff. Then shortest distance 2 and shortest distance 2 took me a while, but it was a good problem. And then shortest distance 3 was basically just shortest distance 2 with like a very tiny twist that was very easy to implement. And so both of those were 2 pointers as the technique that you use to solve the problem. So I'm good on 2 pointers for the day. So now I'm moving on to some different stuff. This is going to be a graph problem. And then after this, depending on how much longer I'm going to go, I might look at some like dynamic programming problems as well. Slightly more difficult than the 2 that I just did. How important is having a portfolio on GitHub or someplace? Is that something companies want to see? Some companies like to see like GitHub activity. I think it just really depends on the company. You probably have to do a little bit of research, but there's definitely companies out there that will ask for your GitHub link, and they'll actually click through and they'll look at like repositories that you've been contributing to. But there's also companies that don't really care about that at all. There's companies that just care about, can you pass their interviews, you know? Like they give you an interview because your resume looks good, or however you manage to get the interview, you know, you can get a referral from people in the company. At many companies, getting a referral from someone internal is basically guaranteed interviews. And then all the company cares about is like, can you pass their interviews, you know? This is my day 1. Well, this is my official day 1. I did this stream yesterday too, but then I decided last night and this morning after the stream that I was going to turn this into a daily thing. So this is my, I guess you could technically consider it day 2, but like officially I'm just calling it day 1. And I'm going to be uploading all these streams to YouTube as well. So, okay, let's think about this. So we get a list of the process IDs, which are the process ID is guaranteed to be greater than or equal to 1, which makes sense because a process that has a parent ID of 0 is the root process. The hardest topics for me, like, I'm not even gonna lie to you, dynamic programming, I've always struggled to wrap my mind around. Like, depending on the specific problem and what it wants, sometimes I can get it, sometimes I can't. I struggle a lot with dynamic programming. I think that's pretty common as well. The stream timing is probably gonna be whatever the time is for you, minus like 3 or 4 hours. I'll try to start then. And I'm basically just going until I feel like stopping. So I don't even know how long I've been live. I guess it's probably been 2 to 3 hours already. If you guys find interesting LeetCode problems that you want me to attempt, I'll take a look at it. If the problem is marked as hard and it has a low acceptance rate and it looks completely ridiculous, I really wouldn't expect too much out of me. Like, I probably won't be able to do it. I would say that like medium problems is really what you really want to grind if you're preparing for interviews. If you can solve hard problems easily, then you're basically good to go. But if you can solve medium problems most of the time, or you can, you know, spend a little bit of time on a medium problem and get to a solution somehow that's accepted, that's a really good sign for how ready you are for interviews. If the interviewer cares about table versus memoization, that would be really weird to me. Because, I don't know, like, some people like to do one and some people like to do the other. And as far, in my opinion, the interviewer should just want you to get to an efficient solution, regardless of if you use a specific technique, you know? Like, as long as you're getting to a good running time, like a good big O complexity, it shouldn't really matter whether it's memoization or table. Yeah, I agree. Memoization is easier. I'm right there with you on that one. There's some tools in Python that make memoization really easy too. I need to learn them, but there's like isn't there like a memoize like decorator or something like that? Func tools. Cache, this might be it. You can basically have a Python function that you decorate with cache. I think it's cache. Oh, there's also an LRU cache. And yeah, it kind of just makes it so you don't even have to worry about like having your own like hash map or whatever. It just does it for you. Trying to wrap my mind around oh, sorry, I haven't really been paying attention to the activity feed, but Mellow Feed and Not Enough Study Streams, really appreciate the follows. This is brand new, like this is my second day streaming on this channel, so I really appreciate you guys coming in and showing. And I'm gonna try to actually solve a problem now, so that I'm not just sitting here jabbering the whole time. You were given, okay, so I think what will work here is if I iterate through the parent process IDs, I can create a new table of, I can basically invert the direction of the relationship and have child process IDs. So it would be like vector of int, CPIDs. So we have PIDs, which is the process IDs. We have PPIDs, which is the parent process IDs. And so now we'll have a vector of ints, which is the child process IDs. And now we want to iterate through all the processes. Let's just store the number of processes that we have in an integer called n. It's going to be PID.size. Oh, thanks, man. When I use man in a generic sense. Thank you. I appreciate that. So I don't do every single problem in C++, but if I ever need to do like anything with hash maps or binary trees, I like C++ because it has a lot of great stuff in the standard library for that. For easier problems, I'll occasionally whip out JavaScript, and I'll occasionally whip out Python 3. Just because I kind of like to keep at least somewhat up to date on those languages. But yeah. So we got that. So now let's go through all the processes, parent IDs. So for int I is 0, I is less than ppid. Okay, yeah, we'll just have it be singular. PID, PPID, and CPID. Dot size plus plus I. And so now what we want to do is, they actually did kind of make it weird because the process IDs are not guaranteed to just be like consecutive integers, which is annoying. They give you just like whatever they feel like it. But I'm gonna treat it so basically I have this PID array is basically a lookup table. So I can, if I in my code treat the process IDs as just like 0 onwards, I can just come in here and look up what the actual process ID is. Yeah, okay. So this I think this will work. So in the PID array, we get the, okay, I think I know how I'm going to do this. I'm going to have a lookup table that lets me look up the index of a process from its ID. So it'll just be an unordered map of int, and it'll be PID lookup. And so then what I can do is for I is 0, I is less than PID dot size plus plus I. And so what I'll do is I'll insert into the PID lookup the process, the like actual process ID, which is the PID at I, and I'll set that equal to I. So that means that down here, when I get a process ID out of this PPID array, I can look it up really easily. So the ID is going to be, here we go, we'll just make it ID lookup, because it's going to work for parents, children, it's going to work for everything. It's going to be the ID lookup for PPID at I. And we don't want to call this ID. This is actually index. This is indexes. I need to keep the ID and the index separate in my mind. I don't like problems that try to confuse you with stuff like this. So int index equals index lookup PPID at I. So for example, for the first one, the parent process of index 1 is 3, and we'll be able to look at that up. So we get that, and then I'll have CPID, and now I need to invert the relationship. So CPID of, here, let's initialize this so that it's the right length. PID.size. Index equals I. Oh no, dot pushback I. Okay, is that right? So we're going through the PPID array. We get the process ID out. It's the parent process ID. So then we want to go to that parent process ID and add to its children array that it has a child at index I. And then I think I can just DFS. So vector of int answer, return answer. And we're just gonna DFS starting at this one, the one that we're killing. And we need to pass in the child process IDs. We need to pass in the answer, and we need to pass in the one that we're killing, kill ID. Okay, I think that'll work. So this is just going to be void DFS. If you're not familiar with the DFS, we're basically going to start at like 5 or whatever index it tells us to kill. We're going to start at that, and then we're going to go to all the children, and we're going to go to all the children's children, and so on and so forth. DFS is a very important concept. So vector of int. So this is going to be the CPID array. And we turn that into a reference so that it doesn't have to copy it every time. And then we have our vector of int answer, which we will be pushing. We'll push every single node in the subtree into the answers array, which is what they want us to do. And they say that we can return the answer in any order, which is nice. We don't have to worry about doing like a specific order of traversal. And then this will be index. And since I'm passing in the index, what I actually want to do here is do an index lookup for the kill ID. Is that right? Okay. So the very first thing we do is we can take the current index from this DFS call and we can put it in the answer. Like that. So we do that. Now that we've added the current node to the answer, we then look at all the children and we do the exact same thing. So I think all we have to do is for int child index. And it's child index because I'm storing the indexes in the CPID array. And so once all this is done, the last thing I need to do actually is come down here and convert all of the indexes back into the original IDs. That'll be really easy to do. So I just go through the child indexes in CPID of index. And this part's really simple. I just DFS there. So DFS CPID answer index. Something like that should work. This is a tree, not a graph, or not a, it doesn't have any cycles, so I don't have to worry about marking spots as visited or anything like that. Abram Harv, thanks for the follow. So the next thing to do is to go through the answer array and update everything. So for int I equals 0, I is less than answer.size plus I. Answer sub I think this will work. Answer sub I equals process ID of answer sub I. Okay, this is probably not 100% right, but this should be fairly close to a solution. No matching number call for a pushback. What's wrong here? Oh, pushback index. Deadly signal. Stack Overflow. I wonder where that's happening. So usually what I do in this situation is I put some logs in the code so I can figure out where it dies. So I can just do like cout 0. Because there's unfortunately LeetCode doesn't have a debugger, so I can't step through and see where it dies. So I can put a cout 1 here. If you have a debugger though, that's definitely better than doing what I'm doing right now. Put a 2 here. Also, if anyone sees the bug, feel free to just shout it out. That's fine too. So if we see 1, 2, 0, if we see 0, 1, 2, that means it at least gets to the DFS. Okay, it does. It gets to the DFS. CPID index, and we initialize it to the number of processes. Is it possible that it's dying here? Oh, okay. So this shows us very easily what the problem is. We just have an infinite, we have like an infinite recursion. It's the recursion is never stopping. What question will you do next? That's a good question. I don't know. You can throw one my way if you want. Otherwise, I'll just go browse the problems section and see what jumps out at me as interesting. So let me just make sure I did all of this right. So I create my index lookup. I go through the process IDs. I put the process ID in the index lookup, and I put what its index is. So basically, I create a map from these process IDs 1, 3, 10, 5 to the index that it actually is, which would be 0, 1, 2, 3. Then the next thing I do is, oh, you know what? Let me just clean this up slightly. So I'll put this up top. Then I can make this n. I forgot to use my, because these are all the same size. So I should be using just n everywhere, honestly. Okay. That's not going to fix it, though. Obviously, I can't have 2 of those. Okay. So it's still Stack Overflow. So then the next thing I do is I go through all the processes. I grab the index of the parent process of the ith process. So for example, for this one, which is the parent process is 3, I would go over here and I have my lookup table, so I would be able to see that the index of that is the first index. So then I push that back. Then I have my answer, and then I just DFS with the CPIDs. So I do my index lookup to get the index of the kill ID. In this case, kill ID is 5, which would be index 3. How is it possible that I'm getting an infinite, like an infinite recursion here? Okay, I think the best thing to do right now is to look at CPID and see what's in there and make sure it's right. So for I is 0, I is less than n plus I, and so we'll see out I end line, and then for int index of the CPIDs of I. We'll see that out. See it out. Followed by a space. So those will all be in a row. And then terminate that with some new lines. Okay, so for index 1, which is parent process 3, we have 0 and 3 as the children, which is 1 and 5, so that's correct. For index 2, which is the 10. Oh, what is this 0, 1, 0, 1? Oh, let me get rid of, this is confusing that I have these other couts here now. Hey, Stockton Wobalski. I didn't realize that was there. Okay. Yeah, we'll definitely use that. Thanks for pointing that out. So 0, 1, that means that process 1. No, wait, that doesn't look right. Is that what the problem is? Process 1 doesn't have any children. Oh, is it because I'm not taking into account when the parent process is 0? It might be. That might be it. Hold on a sec. So when I'm iterating through the parent processes, if the parent process of I is 0, we just skip. We skip this one. Okay, so we're still not getting all the way through the program, but that's right now. So we have 0. So process 1 doesn't have any children, which is right. And with process 1, which is process at index 1, which is number 3, has 2, which is 1 and 5. So that's right. Process 2, which is 10. Does not have any children, so that's right. And then process 3, which is obviously 5, has 1 child, which is yeah. Okay, so the CPID array is right. CPID array is right. So let's see here. We DFS, we pass in our CPID array. We look up the index for the kill ID. So I think what I should do now is let me log the index at each function call of the DFS, and we'll try to figure out why it's doing that. Okay, 33333. Okay. Okay, so I don't know. I'm ashamed of myself for not seeing this bug. At the same time, I'm also surprised that there wasn't someone in the chat who could point it out. This is supposed to be child index, obviously. So what I was doing was when I was calling the DFS function, I was just giving it index again, right? I was basically saying revisit the same node that we're currently at. That's wrong. When we DFS from within the DFS, we should be going to the child index. Okay. Stupid bug. Let's see what happened. There we go. we get the accepted solution. We get the accepted solution for the first test case. Let's take a look at this other test case that they give us. Okay, we get the accepted solution for that too. That's actually a good edge case to test as well. Like, what if there's just one node in the tree and you kill it? Is it guaranteed? Oh yeah, kill is guaranteed to be a process ID. So they have to do kill one here. Okay, so I feel good about this. Let's submit. Oh, look at that, man. This is lightning fast right here. Let me delete all of my logs. Yeah, I like this question, but there's an element of the question that I don't like, which is they force you to have to think about converting between the process ID and like the index of that same process in the array. So the way I solved that was using this index lookup map. So basically I can easily convert from a process ID to an index, and also an index back to a process ID just by using the process ID's array, which is what I did here in the answer. I'm not a big fan of that element of like that aspect of the problem, but it's fine. I think it's still a pretty good problem. And that's it for that one. So let's see what the suggested problems are. Line reflection, serialize and deserialize BST, shortest path in a binary matrix. Shortest path in a binary matrix, I'm not gonna lie, that sounds fun to me. Maybe I just take a peek at what that is. We can also look at the solution. Let's see what the code is. I bet it's pretty similar to what I did. Oh, that's fancy. So this solution didn't even create a separate like DFS function. They just recursively call like the main solution function from within itself, which is smart. So let's see. 0. Oh, but O of n to the O of n, O of n to the n times O of n to the, oh wait, sorry, that's not times. That's the time complexity. That seems bad. Oh, okay. Sorry, I need to read a little bit more before I start like analyzing the code. This is actually a bad solution. I was looking at it, I was like, this doesn't seem right, because they're like, they have an exponential amount of space that they're using here, or time rather. Yeah, so this is a time limits exceeded solution. Tree simulation accepted. We can view the process relationships in the form of a tree. That's what we did. We can construct the tree in such a way that every node stores information about its values, as well as the list of all its direct children nodes. That's what we did. Okay, so they make a node class. That's definitely one way to do it. And okay, so they did basically the same thing I did, which is inside their kill process function, they recursively call this get all children function, which is basically just my DFS function, because get all children effectively is just a DFS. They iterate over all the nodes, and then they get all of the children of those nodes. And then you get O of n, which is what I have. Hash map plus depth first search. That seems like basically the same thing. Hash map, yeah, breadth first search, obviously that will also work for this. Oh, this is cool. Someone took the time to suggest good points to clarify with the interviewer before jumping into coding. What should we do if there's a cycle in the input? Which is, I think that's a good thing to ask, but the description does actually say that that's not the case. Can there be a self loop such that a process is its own parent? And what do we do if there is an orphaned process in the input? Yeah, I agree with this person. Those are good things to ask about. Okay, moving on to the next one. Let's see what this is. Also, anyone who's watching, let me know if you have any follow-up questions, or I could explain parts of the code. Like I'm doing these streams like for me as interview prep, but you know, I'm also streaming it so that people can watch. So I appreciate anyone who's watching, and I'm happy to try to go into more detail about anything. Okay, given an n by n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. A clear path in a binary matrix is a path from the top left cell to the bottom right cell, such that all the visited cells of the path are 0. All the adjacent cells of the path are 8 directionally connected. They are different and they share an edge or a corner. Okay, so this looks like, so I did DFS in the last problem. This problem is a BFS. So basically for this problem, what you need to do is start in the top left corner. And you, for BFS, the easiest way to implement it, in my experience, is to use a queue. And you basically have a queue which represents like the next node that you're going to visit in the traversal of the graph. So you start in the top left, which would be like this 0 tile right here, and then you would look at all of the 8 cells around it, and for the ones that are 0, you would visit those, and the way you would visit them would be by adding them to the queue. And then you would just keep doing that for every single 0. Effectively what this does is it expands outwards in a circle around the node that you start at. In the case of this graph, because we're starting in the top left of it, it would be like a slice of a circle. You'd be going just down and to the right. And then eventually, assuming that there is one, you would find a clear path to the bottom right. And then once you find that, you output the length of it. And okay. Interesting. Another thing that's interesting about this problem is since it's 8 directional, you want to prioritize going diagonally over going you know, up, down, left, and right. Because, for example, let's say that you had the graph 0, 0, 0, 0. Let's say that this is your graph, right? There's several clear paths from the top left to the bottom right. You can go here, here, and then down to get to the bottom right, or you can go down, down, and to the right. Both of those have a length of 3, regardless of which way you go. But because this problem lets you go diagonally, there's actually a path that's 1 shorter, which is going straight from the top left to the bottom right diagonally. So whenever we're doing our DFS, we're going to check out the diagonal squares first. We can keep a marker and do a level order traversal. Yeah. I think that's what I'm saying. I'm not sure if you're talking about something different from what I'm saying. But this would be a level order traversal. But when I'm doing the level order traversal, I'm looking diagonally before I'm looking up, down, left, right. So I actually coded a BFS yesterday, so I have a vague idea of what I need to do here. So let me just create, let me just get the let me just get the dimensions of the grid first. It's always just useful to have, in my opinion, so you don't have to say grid.size everywhere, or grid 0.size. Is there guaranteed to be a clear path? Oh, no, there isn't. So if there's no clear path, we return -1. And then I'm doing this grid 0.size here. Whenever you do that, you do want to check to make sure that there's going to be at least one cell in the grid, and the constraints of this problem do guarantee that. So n is at least 1. So because of that, we're safe to just grab the 0th index. Let's see. Since the goal is to find the shortest possible path, won't you need to visit all possible paths? What if going down diagonally leads to a terrible path while moving to the right leads to a bunch of later diagonals that is shorter? Also, this is a case where memoizing the shortest distance from a given node should be stored. So the answer to the second question is yeah, you can do that. That's actually not how I'm going to do it. What I'm going to do is I'm going to store the distance on the queue, but you can have like a 2D array where like every cell represents the distance to that array. And then, so the first question, so when I say prioritize, so I probably didn't explain it very well. When I say prioritize diagonal, I mean, if I'm looking at like, fuck, I don't even know how to draw this. But yeah, you're right. You're right. You can't just go straight diagonal. You need to also, you need to also go up, down, left, right. But it just I'm saying that I'm going to prioritize diagonal. I'll show you how I'm going to do that. But if I'm at like this cell, then obviously the next cells that I need to look at are going to be all 8 of these cells around me. And so I'm going to add all 8 of these to the queue so that they come up next. And so that's how you get like the BFS behavior out of it. Because the queue, let's say that you're starting at the center. I know in this case we're starting in the top right. But let's say that you were starting here in this middle node. I would add all 8 of these to the queue so that as soon as I get to the next iteration of the BFS, I'm going to be grabbing one of these 8. And then at the next iteration of the BFS, even though the previous iteration added a bunch more tiles to the queue, I'm not looking at those yet. I'm going to keep looking at the original 8 tiles around the starting point. And then once I finish with those 8, then it will start looking at the next layer around it. So that's like the level order traversal that you talked about. But the point that I was trying to make was that when I'm adding these 8 tiles to the BFS queue to do the level order traversal, I'm going to add the diagonal ones first. Because if I can get from this 0 to this 0 in one hop, it's better than getting from this 0 to this 0 in 2 hops, basically. But it is going to be a level order traversal. I don't know if that answers the question, or maybe I'm still missing the point of what you're trying to say. But so we have our. I'm going to use I and j as the coordinates. You can use x, y. You can use RC for row column. I'm just going to use I and j in this case. So I'll have I start is 0, j start is 0, I end is 0, I end is not j, it's n minus 1, and j end is m minus 1. So I like to have those like that just so that I can reference them in the code. It's like a readability thing. Not that I'm saying my code's the most readable code, but at least if you see these variables, you'll know what they mean. I start, j start, I end, j end, all of those. And then, as I mentioned, you're going to have your queue. The queue is going to be a vector of integers, and it's going to be all of the vectors of integers are going to be of length 3, and they're just going to contain the 3 pieces of information that we need. So it's going to be I, j, and d. where I is the current I coordinate that we're looking at, J is the current J coordinate, and D is the distance that we travel to get to this far. So I don't have to do it this way. Like you said, Stockton, I could create a two-dimensional distance array and like memorize the distances to each one. But this works too. If you want, after I finish implementing it this way, I could change over, I could like rewrite the code a little bit and do it that way. That might be interesting. But we want to keep going while the queue is not empty. Keep going while the queue is not empty. And then the first thing you want to do is you just want to get the next thing off the queue. Queue.front, queue.pop. And then what we can do is we can actually extract the information that we want out of next. So I would be next 0. J would be next 1. And the distance would be next 2. That's basically the idea. So you should think of this vector that I put in the queue just as like a data structure that contains 3 pieces of information. Even if you do not put the diagonal first, if the end is reached first at a particular level of the loop, we'll exit. So according to me, we don't need to give priority to anything. Just make sure the direction of movement is correct. You might, yeah, I think you're right. Maybe it doesn't matter which ones we add. Yeah, I think, no, you're right. I was overthinking it. Thanks for pointing that out. Yeah, you're right. I don't have to prioritize going diagonal. I just have to add all 8 of these tiles. I have to add all 8 of the surrounding cells that are not visited. That's another important thing, is keeping track of what's visited. All 8 of the, so out of the 8 surrounding cells of where I'm at, I need to add the ones that are not visited in any order to the queue. And it doesn't matter if I add the diagonal cells first, you're right. Because it's still going to take an extra step to get to the diagonal cell by going like left and up, and at that point it's already going to be visited. So yeah, that's a good point. Thanks for pointing that out. One thing that I like to do in problems like this, so we do need to keep track of where we've been so that we don't go there again. There's a bunch of different ways you can do it. So one way would be, we could have like a vector of bool visited, right? This could just be a 2-dimensional array of booleans that indicates whether or not index I and j has been visited. That's something that we could do. But in problems like this, and it also kind of depends on what the interviewer wants. So you probably want to ask him about this too, him or her. The other thing that you can do is the grid contains zeros and ones. Every time that you visit a 0, you can actually just overwrite that value in the grid to be a 1, and that will make sure that you don't go to it again. Or if you wanted to distinguish between an open tile, a closed tile, and a visited tile, you could do like 0, 1, and 2. You could overwrite the zeros that you've been to with 2s. In the case of this problem, I think it's going to work just fine to, every time that I'm going to visit a tile, to just overwrite the original value in the grid to be a 1 so that I don't go there again. Okay, so one thing that I haven't done yet, which is very important, is we do need to prime the queue with the starting position. So we need to put I start, I end, and 0 in there. So once we start going through the queue, we're going to be starting at I start, J start, and 0. That's where we need to start. 0 effectively stating that it's taken us 0 hops to get to the start. Because this problem requires you to specify the number of nodes in the path, I think I can actually start this off at 1. The alternative would be, when I return, I could just add 1, but I might just start this off at 1, indicating that the current path has 1 node in it, which would be the starting node in the top right. Okay, so what should I do next? The next thing to do is, after I push the starting node onto the queue, I'm going to override it with a 1. Also, is iStart guaranteed to be a 0? I assume that it is. Let me look at the constraints. Grid ij is 0 or 1, so that doesn't help. So it doesn't actually guarantee that the bottom right cell is a 1, which is funny, because we could just short circuit that situation at the beginning, right? We could just do if grid n minus 1 m minus 1 is 1, we can just return -1 because we already know it's impossible. That's a super minor optimization, but there doesn't seem to be any specific reason not to do it. A clear path. Okay, so we could do the same thing for the starting tile too. You know what, I should do it down here since I created these variables already. So the start tile also needs to be a 1, otherwise it won't work. So if grid of, this is going to be I end and j end. If it's a 1, then it's already impossible. Similarly, the start tile also has to be a 0 because the entire path has to have zeros on it. So if grid of I start j start equals 0, or grid of I end j end equals 0, sorry, 1, then we return -1. It's a really minor optimization, but they probably have some test cases for that we'll just pass instantly because we have those cases in there. Okay, so now that we have that, so we push iStart and JStart into the queue, and then the next thing that we should do is turn iStart and JStart into a 1. And that just, we already know that it's not a 1 because otherwise we would have exited the program here. So we turn it into a 1, and that's just kind of indicating this is the very first tile of many that we will not be returning to. Okay, so I think that takes care of all of that. Keeping an eye on the chat in case you guys have any questions. Let me just create a integer array up here, and if it works, I'll explain afterwards what it's for. Is that right? You guys have no idea because you probably don't know what it's for. So here's the situation, right? We basically have a mini tic-tac-toe board at every single iteration of this loop. We're gonna pull off an I and a J and a D, and we need to go all the way around. We need to go to you know, up, down, left, right, and all 4 of the diagonals. We need to go check those out to see if we can continue the path from those. And so what I'm trying to do is I'm trying to make an easy way to look at all those. And so this is a way that I've done it before. Let me comment that out for a sec. If you guys already know what this is, I can just skip explaining it, but it took me some time to figure out what this is myself. So let's assume for a second that you don't want to go diagonally, you just want to go up, down, left, and right. you can use this array to do it really easily. So basically, you should think of this array as, don't worry about the whole array, just look at consecutive pairs of numbers, right? So 1, 0, 0, negative 1, negative 1, 0, and 0, 1. So so even though this array has 5 elements, there are 4 consecutive pairs of numbers. Each pair represents yeah, a vector of pair would work too. I kind of like this because it's spiffy, although a vector of pair would probably be easier to read. But yeah, just finish up the explanation for anyone else. Like this right here, 1, 0, that's going to make you go down, right? Because you're going to take the current I and j, and you're going to add 1 to I and 0 to j. So if you look at all 4 of these pairs, it represents all 4 directions. You've got 1, 0, 0, negative 1, negative 1, 0, 0, 1. And so I always use that for problems like this, but what I'm trying to do right now is create the exact same idea, but for going in 8 directions. So you start off with 1, 0, 0, negative 1, negative 1, 0, 0, 1. Then we need 5 more. 1, negative 1, negative 1, negative 1, negative 1, 1. Okay, I think this is right. So I'm going to try that. So basically we'll iterate through this array 2 elements at a time, and we'll use those as basically like a delta to add to the current I and j, which will move us in all 8 of the directions. So using it is fairly straightforward. You'd have like int idir equals 0. Idir is less than 8 plus plus idir. I just being like the index of the direction. Just confirming, yeah, I'm pretty sure that's right. So then what we do is we have our current I and our current j. So what we're going to do is create a next I and a next j, and I'll just call those ni and nj. And so it's going to be dir of idir, or sorry, it's going to be I plus dir of idir, and then the next j is going to be j plus dir of idir plus 1. And so it's just, I don't know, I like it. It's kind of nifty. I mean, you could actually write this out as like eight separate cases, but being able to just iterate through it in a loop, I prefer. So we have our next I and our next j. We need to make sure that they're in the bounds of the puzzle. So ni needs to be greater than 0. We'll write it this way. If it's out of the bounds of the puzzle, we just continue. So if ni is less than 0, or ni is greater than or equal to n, or nj is less than 0, or nj is greater than or equal to m, we can continue. Basically, we just skip that. Can't go there. Other situations where we want to continue, and so since if we get to this part of the condition, we already know that all this is false. So we know that we can safely check what's in the grid at ni and j. So, or if grid ni nj is a 1. And so that's how we're going to make sure that we don't revisit cells that we've already visited. We continue. So if we get here, we know that we can move into that cell. So we push it into the queue, right? I think. Ni, nj, and now we take the current distance and we add 1 to it. So we got the distance right here, just add 1. And then we also make sure that we don't go to it again. So grid ni nj equals 1. I think that's good. I think there's like we also have to test for the end condition. I think I could test for it like out here. Oh no, I can't. I have to test for it in here, because if I test for it out here, it will already have been. Oh no, I can't test for it out here. Sorry, I'm being stupid. I can test for it right here. So if I equals I end and j equals j end, then we're good. We can return distance plus 1. No, we can return distance. If I was doing this logic here, I would have to do distance plus 1, but I think this is right. And I think I'm going to run the program now. Okay, excellent. We got accepted for the easy test case. Let's take a look at some of these other examples. So we have that one's supposed to be 4, and this one is supposed to be -1 for impossible. Okay, cool. So we're getting the expected output for the 3 sample test cases. I think I've said this every time, but in a interview situation and even in a contest situation, like if you like to do the LeetCode contests, always try to come up with some more test cases, but I don't feel like doing it right now. Maybe I'll start doing it, but I'm just gonna submit. We did it! We got that one accepted. The runtime is kind of slower than I was expecting. We will run it a few more times. No, I don't have 2000 rating. Nowhere near that. I'm at 1799. Like, I had a spike in rating here because I was doing a lot of coding contests, so I went from what, like 1400 to 1824, and then I like took a long break from LeetCode. I was saying this earlier, but like if you look at my LeetCode activity, like I have barely any for like the last 2 years, and then in 2021 I would expect that this spike in rating coincides with this jump here in like activity on LeetCode. It's all right. I mean, like I'm still really intimidated by some of the players that can solve these like coding challenges like in like 3 minutes, you know? Like there's people, they'll come here to the problem description, and then like without even thinking about it, they'll like write 10 lines of code and it'll be solved. You know? And like even for some hard problems, like they're just so good. I don't expect to ever be that good. Like literally, I just want to get good enough so that I can have fun in the contest, and so that I can get work. But okay, what I am curious about though is 1400. Yeah, but how long have you been doing it? Like, you really got to grind this out. If you put in the time, you know, to like learn and practice, like you'll get better. I don't even know if I'm technically 1700 now, because like I said, I took a long break. Like maybe I'll be 1700 in a couple of months. Once I remember all the stuff. So my runtime was only faster than 25% of C++ submissions, which I'm actually a little disappointed about. I wonder what I could be doing here to make it run faster. Usually I don't spend much time worrying about this, but how do you make this BFS faster? Because we're not visiting any tiles needlessly. Thanks again for the follows, and anyone who's in here watching, I appreciate it. I honestly, I said this before, I'm doing this mostly for me because I do need to review these concepts. But I figured, you know, if anyone wants to hop in and chill, that'd be cool. And there are some people here watching and chatting, and I'm actually really thankful. I think it's cool. Hopefully you guys are enjoying and learning, and again, you can ask for clarification on any of these lines of code. You could be like, what the fuck does line, I don't know, 33 do? And I would go back and explain it for you if you want. But what do I do here to make this faster? It might be, I wonder if doing the two-dimensional array of distances would make it faster. Placement prep. 1600 and just started for my placement prep. I apologize for not knowing, but what is placement prep? Is that like for a job or for school or for boot camp? Yeah, I'm not sure what placement prep is, but congrats on the 1600. That's dope. That's a good level. I'm gonna Google it too, even though you're probably typing out right now what it means. What is placement prep? Step-by-step guide for placement preparation. Oh, so this is for like college, I guess, according to this. Go away. Campus placement season. Well, that's cool, man. Best of luck with the placement prep. I hope it goes really well. And then I hope the placement goes even better than the prep. Oh, job for a job. Okay. Yeah, I hope the prep goes well, but then I hope that once you get the job, that goes even better than the prep. So I don't know what I can do to speed this up, honestly. Not enough study streams. Thank you for stopping by. I appreciate it. Thank you for the follow an hour ago. Like I said, I'll be doing this every day for a bit. So maybe I'll see you in the chat again. Have a good day, night, evening, whatever time it is where you are. So I actually thought overriding the values of the original grid would make this run faster because it is like using less space, you know? It could be the way that I'm doing the queue. Like maybe it's because of how I'm initializing these vectors for the queue every time. Zero one matrix. Now I feel like a real noob. What is a 0-1 matrix? Is that what you're talking about? Are you talking about the 0-1 matrix LeetCode problem? Given an n by n binary matrix, return the distance of the nearest zero for each cell. You mean like pre-calculate? Okay. So pre-calculating the distance from any tile to any other tile for all the tiles in the cell. That seems like it would run a little slower because we don't need to know that. We just need to know the shortest path from the top left to the bottom right. I'm tempted just to look at the solution. I think, yeah, let me just see what they... Okay, breadth first search, overriding input. That's what we're doing. This 0-1 matrix problem is interesting. I'm going to keep this one open. I might look at this. Because this sounds like it might be... This sounds like it might use some memoization. Yeah, this is dynamic programming. Yeah. That's an interesting problem. I might look at that. So... Where's the code? Okay, here we go. Okay, and this is what you were suggesting earlier. I mean, this is just the same. This is the same. Oh, they store the distance in the grid. That would work too. I don't know if that's going to speed my solution up at all. But you could use the grid to store the distance. Get neighbors. Oh, this has got to be... They're generating like a neighbors array using a function call. So this is kind of what I was talking about earlier. Like, if you look at how I have this line of code at the top of the file, and then I have these 2 lines of code, these 3 lines of code here. Like, that's 4 lines of code, right? To do what this Java solution is doing in like 30. Okay, 30 might be a little bit of an exaggeration, but a lot more than what I'm doing. So that's kind of why I like this. That's kind of why I like this solution. Linear time, linear space, makes sense. Breadth first search without overriding the input. Yeah. So they just have a visited set. I bet there's a Python solution that uses a set of tuples. Am I right about that? Yeah, I am right about that. Yeah. Visited is a set of tuples. I do like how you can do that in Python. It's really nice. Okay, and then a star. Oh, you know what? This is probably why. I bet this is why my runtime is so low, because I bet a lot of people are doing a star, and for this problem, a star makes a lot of sense. A star is basically just a tweaked breadth first search, where instead of expanding outwards from your start node in a circle, if you know where you're heading, just like generally, like in our case, we know we're going from the top left to the bottom right. Instead of expanding in a circle, kind of like blindly, you do still expand outwards in every direction, but you expand more towards the place you're trying to get to. So I bet this would work a little bit faster. Yeah. You got to use the priority queue for the A star. Let's see. Yeah. I haven't written an A star algorithm in so long. If I was in an interview situation, probably what I would do is I would implement a normal BFS, and then if the interviewer was like, "Oh, nice, how can you speed it up?" then I would just explain to him like what A star is. And if he asked me to implement it, then I would just kind of like start trying to implement it. I don't think it is, but I think an interviewer could be impressed if you mention it, you know. It's kind of like name dropping. Just be like, "Oh yeah, A star," and then they'll be like, "Oh, nice." Okay, I think that's all I'm going to do for this problem. I'm interested, but also slightly intimidated by the 0-1 matrix problem. Given an m by n binary matrix, return the distance of the nearest 0 for each cell. The distance between 2 adjacent cells is 1. So for this one, oh, and distance means, is it like, can you go diagonal in this? Oh, I guess not. I guess they imply that you can't go diagonal when they say this. The distance between 2 adjacent cells is 1. And then, okay, so the output for all the zeros, okay, oh, I think I understand how to do this problem. This problem is also BFS, I think. Like, basically, you just take all of the zeros. What I'm thinking for this problem is that you take all of the zeros and you just add them to the queue that you're going to BFS with. And then you're basically searching from every single zero until you uncover every one on the grid. Yeah. Well, there's like a BFS technique where you start from multiple starting points. BFS starting from multiple start points. Flood fill BFS. That's kind of what I'm talking about. Flood fill BFS. Is that how you solved it? Did you? I'm assuming you got that problem, right? You got it accepted. I feel like the solution to that is a flood fill BFS. I could write it, but I've also done 2 BFSs so far today, so maybe I should code up something slightly different. I'm also curious about why they label it with dynamic programming if it's just a flood fill BFS. Okay, I'll write up the solution to this one just because I'm slightly intrigued by it. I think if I just BFS from every single zero, graph-wise, that approach is correct, but DP-wise, there is a very efficient solve. Interesting. But wouldn't a BFS run in linear time? What time does the DP solution run in? It can't be better than linear. You have to look at every cell at least once, right? Or maybe it's just like a prettier solution, like code-wise. I'm interested. I'm interested. I'm interested. Okay, I gotta use the bathroom. I'm not done coding yet. Please enjoy my Be Right Back screen that I added earlier today. Very proud of it, but I gotta use the restroom, so be right back. Okay, I'm back. I'm back, and I saw your message about the DP solve being very intuitive. So let me think about that for a minute. So how would you DP this? I mean, the distance from every zero to itself is 0. See, it's hard for me not to think about this in terms of a flood fill BFS. Also kind of waiting for my heart rate to come back down because I like ran to the bathroom and ran back. And I'm also slightly out of shape. So those three things combined, I need to start doing more physical activities. Okay. Okay, so for the DP, if it's linear, that means that you're doing here, let me just write matrix.size matrix 0.size and we know that there's at least one cell, so we're good with the matrix 0.size. So you'd have like for int I equals 0, I is less than n plus I. I'm just writing a double for loop just because I'm pretty sure that's going to be necessary, but I don't exactly know what I'm writing after I finish this. So if the current cell is a 0, then you know that it's just 0. If the current cell is a 1, then if the current cell is a 1, then it's basically the distance to the closest 0 that we know of that's adjacent to the current cell, right? And the only ones that we can possibly know are the ones that are above and the ones that are to the left, because we haven't gone to the right yet. We haven't gone down yet. But then again, so let's say that I update the current cell, the solution, like we need a, we're gonna need an answer vector, obviously. Vector of int answer, n vector of int m. So we've got that, and then that's what we return. You know, if I was a professional coder, I'd probably call this DP, but I'm calling it answer because this is my solution and I can call it whatever I want. Okay, so let's just do what we know. We know that if the matrix of ij is a 0, then we know that answer ij is also 0. However, if matrix ij is not 0, that means that it's a 1. And that means that we need to figure out the shortest distance to a 0. And all we have to go on, at least the way that I'm writing the code right now, which might not be right, is we can check above, assuming it's not out of bounds, and we can check to the left, assuming that it's not out of bounds. And those answers are already filled. But what I'm wondering though is, what about to the right and down that we haven't looked at yet? We can't look to the right. So the DP solution, does it also start from the ones or the zeros? Or does it go through the grid like one cell at a time like I'm doing now? Not 100% sure. I honestly, like, I don't know if I'll be able to come up with the DP solution to this. Let me just think about it for a little bit longer though. I don't want to sit here staring at this for too long because that's not very exciting for anyone who's watching. Like for example, if we're at cell ij and it's a 1, and then we're like, okay, I have to base cell ij on I minus 1j and j and ij minus 1. So I look at the cell that's above and I look at the cell that's to the left. I can get an answer from there, but it might not be the shortest one though, because there could be a 0 sitting to the right. Oh, okay, yeah. That's probably what I would have done if you hadn't said that there was a DP solution. I do kind of want to figure it out. Are there any hints? There's no hints. More problem writers need to do hints, because I like staring at the problem for like 10-15 minutes, then uncovering a hint, you know, staring at it for another little bit, uncovering another hint. Let's see. Because the way that I'm thinking about it right now is that I'd have to like come back. Oh, wait, do you do 2 passes? Is that what it is? You go from the top left to the bottom right and you do the DP the way I was describing. And then you go from the bottom left to the top right and you do the DP like in reverse. Sorry, you go from the bottom right to the top left. And you update any values that you find that are better. That would work, right? Because after I do one full pass of the DP, I know that my answers are all right relative to what I had already calculated about the rows above and the row, basically everything. You know, I can look above and I can look to the left. And then when I do the pass the other way, I start at the bottom right. Oh, that is it? Okay. Thanks for confirming. I'll implement it that way just because I already did some BFSs today. Okay, so if it's 0, it's ij is 0. Wait, so let's initialize these to, let's initialize the whole answer to like infinity, right? Numeric limits. Also, 2 passes, yeah. Since you already know that, and now I know that, and I know that I could implement that, I don't know if it's worth proceeding with this problem. I don't know how many viewers there are. I have the view count turned off. But I don't know if it would be valuable for either of us really if I implemented that right now. Maybe I'll just star this and come back to it later, because that is kind of interesting. I'll just put this in here. I'll leave myself like notes in the code or something. Numeric limits, int max, right? And then here, just so that I remember what I was doing when I come back later, I'll do DP. And then in order to get it to save a copy of my solution, I'll just submit, even though I'm going to get wrong, or okay, compile error. return DP. Okay, so we get the wrong answer. Oh wait, submit. We get a wrong answer. I don't really care about. I honestly, like, I don't really care about my percentage of accepted versus wrong answer versus you know, time limit. All I care about is getting the problem right eventually, especially when I'm not in like a contest situation. So I'm gonna leave this problem for now. I'll leave this tab open somewhere else, and I'll find something else to do. That is cool though. That's cool that that has a DP implementation. Let's see. Let's look at Amazon's questions. Let's see. Implement stir stir. The hell is that? It's easy, so I'm probably not going to solve it, but what the hell is stir stir? Oh, okay. It's just needle in a haystack. Count and say. Oh no, I like to have questions that are asked a little bit more frequently, because I am trying to actually prepare for interviews, so I'm looking at this frequency column and taking it somewhat seriously in deciding what problems to do. Basic calculator 3, premium problem, 48% acceptance, and hard. I'm curious what this is. Let's see. Implement a basic calculator to evaluate a simple expression string. The expression contains only non-negative integers, plus, minus, multiply and divide operators, and open and closing parentheses. The integer division should truncate towards 0. You may assume that the given expression is always valid. All intermediate results will be in the range of an integer. You are not allowed to use any built-in function which evaluates strings. Oh, that's funny. Yeah, this would be easy to solve in JavaScript, right? And probably other languages as well, but like in JavaScript, just like literally take the string and throw it into an eval. This is a fun problem because it requires you, like, at least the way that I would approach this is I would build an expression tree out of the out of the string, and then once you have it as a tree, it's pretty easy to solve. So you'd have your root, which is the whole expression. Root is just the whole expression. Let's say that you're doing like 2 times 2 plus 2. Your root would equal that whole thing. 2 times 2 plus 2. And then you would take the highest precedent operation within there, which is the multiplication. And so what you would end up with is you'd have 2 children of this tree. The first child would be 2. Yeah, you'd have 2 times 2. Wait, is this right? Oh, sorry, there has to be like operator nodes. You'd have like a multiplication node here. And then you'd have, so you'd have something like a plus operator as its own node. I'm really bad at creating trees in plain text. And then over here you'd have a multiply, and then you'd have the operands as children of that. You'd have a 2 and a 2. You'd have like that, and then over here you would have a 2. So if you can parse the expression into a tree form like this, then it becomes really easy, right? You just solve it from the bottom all the way up. I might do that later. Let me take a look at the question you suggested. Okay, it's hard. You threw me a hard question. Lots of upvotes though. Oh, look, it's already on one of my lists. Have I? Oh, okay. This is a good one to do. Back in 2020, I tried this one. Apparently 3 times, and I got all wrong answers. So, let's see. Given an unsorted integer array nums, return the smallest missing positive integer. You must implement an algorithm that runs in linear time and uses constant extra space. That's pretty intense. The smallest missing positive integer. Okay, so... So I imagine what happened. Oh, is it? Gotcha. Yeah, that's a good point. The tags aren't always the best. I imagine what happened. This is what I used to do this, and I still do it sometimes, is like, if I get wrong answer a bunch of times on a problem, what I'll often do is like quote unquote give up, but not really give up. I then go to the solution and like learn it, but I don't just copy and paste the solution in. I like flag the problem for myself and I come back later. And in this case, it's much later, so I don't remember what the solution is. But hopefully, having read the solution previously, I'll have some idea how to figure it out. So the constraints are that there are 500,000 numbers tops, which explains the linear time constraint. And all of the numbers are within the 32-bit integer range, both positive and negative. You have to find the smallest missing positive integer. So that's going to be, in many cases, that's just going to be 1, right? But it might not be 1. So let's see here. So can I just... Oh, okay. I see why they want constant extra space, because if I could use a set, I think I would know how to do this. What I was thinking is you just run through the array. You start off by assuming that the smallest missing positive integer is 1. But then if you find it, now the smallest missing positive integer is 2. But what you kind of do is, as you're going, you just throw all of the numbers into a set. So then you check to see if you had 2 before. It's more of an ad hoc sort of question, so I liked it when I solved it. I see what you mean, like, yeah, I think I understand what you mean by ad hoc. And you can't sort the numbers because then it would no longer run in linear time, obviously. Sorting the numbers would increase it to n log n. So essentially you get 1 pass. Let me just write some boilerplate code here. You get 1 pass, and then after that you have to return the answer. So let's think about this. For the first example, we have 1 and 2, which means the smallest missing positive is 3. The second example, the smallest missing positive is 2, right? Because we have 1. Then the third example. Oh wait, so do I keep track of like, would it help to keep track of the minimum number in the list? Like I can iterate through nums and I can keep track that 7 is the smallest number in there pretty easily as I'm going. Then once I get to the end, does this work? No, this doesn't work because of negative integers. But like negative integers, I just ignore. Negative integers, I could just skip. They don't make any difference. Like I see a negative integer, I'm like, oh, it's a negative integer, and then I just say goodbye to it and move on. So for this test case, I would iterate through and I would come out the other side knowing that the minimum number in the list is 7. And so knowing that the minimum positive integer, right? I'm just keeping track of the minimum positive integer. Come out the other side knowing that the minimum is 7. And so because of that, I know the answer is 1. One hint is, as it is positive, you can use your array as a map. Right. So like, if the index of the array, yeah, this is silly. This is very ad hoc, like you said. Although, I agree with you that it's a cool problem. I don't know if I would have come up with that by myself. Using the array as a map. So basically like index 1 of the array would represent integer 1. Index 2 of the array would represent integer like 2. Oh, and so like nums sub I I think there's an important observation that I need to make. Something about like, cause there's a lot of positive integers, but obviously we only care about nums of them, the length of nums of them, right? Like we don't need to, I mean, we can't, based on the requirements of the problem, like make nums bigger. So whatever the length of nums is that like the largest integer that we care about? So if let's get the number out real quick. So int x equals nums of I. Like I have an idea of how to do it, but I don't want to just code it up without being sure that it's right. Like so if x is like within the range of the array, then we would update nums at x. Something like nums of x equals negative, so just some special value that indicates that x is here. Like negative, like this wouldn't work exactly because -1 is a real value that we could get. We could just get rid of all the negative numbers though, it doesn't matter. We could change them all to be 0. Like the first pass of the, I could do a pass that just, if for all the negative numbers, just make them 0. And then I can use -1 as like a, or -1 and -2 as like a special value. Let me just do that real quick. If nums of I is less than 0, nums of I equals 0. Is that right? I'm assuming that I probably need to do that. So then any negative values. But then the thing is, nums of x though is still going to be an element that I need to check, so I can't just throw it out. Now you kind of threw me a curveball here. What do I do with nums of x? Nums of x question mark? If nums of x is... Oh, do I have to do like a loop in here? I have to do another loop in here that just like jumps around and updates numbers until we're good, basically. And I don't think that would increase the time from constant to like n squared, because then we wouldn't need to look at those again, right? Like if I ever swap it with the position. Nums of x Oh, wait. And I make it negative? Wait. Num sub x equals negative I? Negative num sub I? Well, hold on. If x is 0, continue. Otherwise, x is positive, and so we want to flag at num sub x, so num sub x that it's there. But then I need to do something with num sub x first. You're saying I put it here? I'm not sure I completely follow, unfortunately. Num sub I equals num sub x. Well, I need to jump around here, right? Like I need to go. So I set num sub x to -1, but then I have to look then at related topics. It lists hash table. Oh, it lists hash table. That's actually like a hint right there, because they say constant extra space, but then they say hash table. So just looking at the related topics is kind of like a mini hint of what you're supposed to do. Think about how you would solve the problem in non-constant space. Can you apply that logic to the existing space? Yeah, we got that. We don't care about duplicates or non-positive integers. We got that. So hint 1 and 2, we figured out. Remember that O2 of n equals O of n. Okay, we got that. Like I'm already doing that. Let's see. I'm like secretly looking at the chat, waiting for you to throw me another bone. But while I'm waiting on that, waiting for you to decide whether or not you're gonna do that. What I'm thinking is, so we want to update nums of x to be -1, just as like an indicator that x is. Oh well, so if x is greater than the length of the array, that's another important question. If x is greater than or equal to, what if it's equal to? Do we still throw it out? Do I need to treat 0 as 1? Just everything is just shifted by one thing. Let's just assume right now that I can do it this way. If x is greater than n, greater than or equal to n, that means that it's a really large, potentially a larger integer than we care about. Like, because does it mean that there has to be a gap before that number, right? Okay, I think I need 0 to mean 1, right? Like what I want to do is nums of x minus 1 well, should I have insert mode turned on? Nums of x minus 1 equals, say, -2. So -2 would mean x is in the array. Oops. So this is like flag that x is in the array. That's what that's doing. So 0 means 1, effectively. Then comment that out for a second. So then what I can do is, if x is greater than n, let's say that let's say that nums is 10 long, right? And we get an 11. We have the ability to store 1 through 10 in the array by using this -1 thing. We have the ability to store it. So if x is equal to 11, we don't have room in the array to store that. Oh! But it could be... So either it's the answer or it doesn't matter, right? Let's say that let's say that the length of nums is 10 and we get a 12. Then the answer is either 1 through 10 or 11. The answer cannot be 12. So we do need to, if x is equal to n plus 1, that's a possibility for the answer. Let me just write that here. If x equals n plus 1, I'll just do, I don't know if this is quite right yet, but I'll do something like answer is the min of the answer and x. If x is greater than n plus 1, just so that okay, and sorry, this needs to be a -1 here because I changed it up there. So if x is -1, that means that it was originally a negative number and we don't care about it. If x is equal to n plus 1, that means we don't have room to store its presence in the array, but it is still possible that that's the answer. So right now I'm just using this logic here to store it in the answer. Now if x is greater than n plus 1, we actually don't care about it, right? It's not possible for it to be the answer. Oh, you know what? This is easier than okay. I can actually start the answer off at n plus 1, right? I think. I start the answer off. So if the array has 10 numbers in it, then assuming that those 10 numbers are the numbers 1 through 10, then the number is 11. So the answer can never be greater than n plus 1. So we start the answer off at n plus 1. And then in here, now we don't have to do this anymore. If the answer is -1, that means it was originally an integer, or it was originally a negative number, so we ignore it. Or if x is greater than n plus 1, we can ignore it, because it's not possible for that to be the answer. Okay, that's progress. I feel like that's right. So now that I got that out of the way, I think that's valuable, a valuable observation. X is so basically x is not -1 and x is not greater than n plus 1. So we get here and we know that x fits in the array, so we can do this, right? We can flag it as -2 in the array, and that should work. But the problem is, in doing so, we overwrite the value that's at nums of n plus 1, nums of x minus 1. So what do I do with that? You're saying swap it. You were saying swap the element. So like bring it here to nums of I. Bring nums of x minus 1 to nums of I. Oh, and then do it again. Right? That's what you're saying. So this is going to be, I'm going to have some kind of loop here. So while nums of I is I'm trying to wrap my head around this. So I want to do nums of x minus 1 equals -2. Then what I do, so in order to do that, I can make, so I see what you're saying, I think. So num sub I is going to be equal to num sub x minus 1. We can do that. and then we can do that. And then now the number that was stored at x minus 1 is now here. But now we want to continue this until num sub I is, until we're like done, right? We want to continue. We kind of want to just restart. Maybe this is not a for loop. Is this just a while loop? Let's try that. Int I equals 0. While I is less than n. Okay. Plus I here. Continue. Is this it? Is this the solution? Did I just get it? So then I do that, but I don't increase I. I don't, and it'll just come back in and do it again. Okay, so if x is -1, if x is -2, that means we already dealt with it. I think that's how we're gonna get the linear solution. So just if x is less than 0, basically, we continue, we increase I and we continue. Nums, we bring whatever was there here, and we store it, and then we flag that there, and then what we do is, now we have our hash map done. We have our hash map done now. So the possibilities, the answer is either 1 through n or it's n plus 1. So we just start off at 1 and we iterate through. For int I equals 0, I is less than n plus I is 0, I is less than n plus I. Oh, we want to go, no, we should just do this in reverse. I equals, is that right? Yeah, I think that's right. I is greater than or equal to 0 minus I. If nums of I is not equal to -2, is that right? What happens if it's not equal to -2? Something like this. If it's not equal to -2, then we update our answer to be I plus 1. Is that right? Run code. Addition of unsigned offset. Oh, less than or equal to 0. Okay, we solved that test case. Use the example test cases. Oh shit, dude. Is that it? Not quite. Last executed input was just... okay, so I think I might just have an edge case here. I mean, the expected output for this is obviously just 1. We didn't have any negative numbers. We grab the 2. It's not greater than n plus 1. Yeah, thanks, Mellowfeet too. Yeah, sorry that I took so long on this one, but thanks for shooting it over. I think it is a good brain exercise. Thanks for the hints, and thanks for stopping by. I really appreciate it. Maybe I'll catch you another time. I think I am close to having this, though, so let me, after you leave, I'm going to try to figure this out. X less than or equal to 0. Seems good. I agree. Where is the runtime error happening? It's got to be in the while loop, right? So n plus 1 is 2. Wait a minute, so n in this test case is 1, so 2 is not greater than 2. I just need an extra case here. Wait, is this just greater than or equal to? Is this just greater than or equal to? Is that what it is? No. I thought it might just have been a silly thing. Yeah, that messed it up. So if x is equal to n plus 1, what was my I output 3. Right, obviously I output 3. I think I just need to, what do I need here? Like a, is this what I need if x is not equal to n plus 1? Is this for these? No. Okay, I need to just think about this here for a sec. The problem seems to be that I'm just not handling the specific case. Where wait, so what am I expecting to happen here when they just give me an array with 2 in it? The answer is 1, obviously. What we really want to have happen is just not throw an exception here, because this will detect the answer to being 1. It'll go through the only elements of the array, see that it's not -2, and it'll set the answer to I plus 1, whereas previously the answer would have been 2. But for the case of x equals n plus 1, so when I added that fix in, it broke the next test case, which is just 1, 1, because I was saying 3, and it should have been 2. It's really frustrating being like so close, but there's just some stupid little thing wrong with the code. Hold on a minute. If nums I is equal to nums of x minus 1, then we also do that. That made it even worse, dude. Okay, let's go back to where it was at least mostly working. So, hold on, let me... Is it working for all of these 4 cases? No, that's still TLE. No, it's not. 3, 2, 1, 3, 3, 2, 1, 2. Why did I say 3 for this when it's obviously 2? So I would start off by kind of assuming that it's 3, but then man, I don't know. I know that I can solve this, but I think my brain is starting to get fizzled out. It's annoying because I'm so close, dude. I'm so close. Okay, so let's try to think about what happens in this 1-1 case. So we come in here, we get the first one, we see that it's in the bounds of what we care about, so we don't do that. So I say numsI equals numsI of x minus 1. So basically I move the other 1 over. So we have 1 1, and then after the first iteration of this loop we have 1 negative 2. So basically we flagged that 1 exists. Oh wait, no, that's not correct. That's not correct. Negative 2 would go here. So what would happen is we would move the 1 over, but then we would override it with negative 2. And so then we'd come into the loop again at the same index. This is less than or equal to 0, so we would proceed. We would proceed to here. Oh, I see. Because then as soon as we come here, we try to move this up here. So this is where the whole duplicate numbers thing comes in. We don't want to copy the number over if what's already there is negative, right? So if nums sub I Huh? Wait, hold on. Let me get all my test cases and just copy them over to Notepad. I just want to look at this 1-1 case for a minute. Right, so that's what we get. We say negative 3, but it's supposed to be, we say 3, but it's supposed to be 2. And that's because we start off with 1, 1. We come in here, we copy, we basically copy it to itself. And then we set x minus 1 to be negative 2. So that's how we get this. And so far that's right. Negative 2 here means that 1 is in the array. Then we come in again. We have not changed our index, but then we see that the index we're at is negative. So we increase I and we continue. So then we come into the array again, and now we got 1 again as our x, which falls within these bounds. So we come down here and we copy. Oh, okay, we copy the one. We don't. Yeah, maybe that is right. Maybe if nums of x minus 1. We only want to do this if nums of x minus 1 is greater than 0. That's the only time we want to copy that number. Is this, I'm trying to figure out, is this what I'm missing? Just that if statement right there? Run the code again. Else plus I. Okay. So that solves the 1-1 case. Now, how are we doing with everything? Oh my god. Okay, 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 okay. I'm so nervous because I really want to solve this one. Am I right? No. God damn it. Okay, 0, 1, 2 is the next test case that we're not doing good in. Let's try to figure out what's wrong with this. So why did I say the output is 1? Okay, so same thing as before. Literally figure it out one at a time. So we start off with 0, 1, 2. Then we come in there. The first number is less than or equal to 0, so we skip it. We skip the 0. We come here. We got 1. So what we would do then is we would make sure that wait. Okay. All right, now we're getting into the meatier stuff. This is honestly, don't learn from me. This is a really terrible way to solve these problems. Just like fixing the code one test case at a time. But I'm kind of getting burned out. I've been doing this for a while today. The expected answer is 3. No. Yeah. The expected answer is 3, but I'm saying 1. So let's try to figure out why that's happening. So we start off with that array. First thing that happens is all the negative numbers get changed to be -1. Which doesn't change anything about the array, because the only negative number we have in here is -1 already. So then we come in at this index, it's less than or equal to 0, so we skip it. We come to the 4. 4 is good, so we check to see what's at the index, which would be the third index, which would be here. So what we would end up doing is we would end up with, I think, -1, 1, is that right? 2, -2, 9, 10. So basically we updated the third index, we updated index 3, which corresponds to 4 to be -2. Here, something else that will help is
just snatch them all up.
if I just print out the array each time here. For int x of nums.
And that's one of the reasons why I can churn stuff out, is because I don't have a problem with reusing or borrowing something that I heard.
Okay. Okay, yep. So that's the same thing that I thought we would get.
And I used to.
Now the correct answer is 3.
Creative. But I quickly found out that I am not original or creative. I can't.
What's the next thing that happens? Looks like we don't do anything. And then zero and 2. Why doesn't?
And I very much doubt, anyways, that any of the people that I listen
Oh no, we would
to
come
first
to the
ones
1.
think of a particular
Okay, yeah, no, we're good.
So once you
0,
get over that,
1.
sounding good is easy.
So we flip this index to be -2, which means that we've discovered that there is in fact a 1 in the array.
No one will know.
No, wait a second.
The new generation now can steal everything from the older generation and pretend like it's theirs.
Ooh, it's kind of controversial.
Okay, so the last thing, let's just make sure that this last log is right. So this is the last thing that we say the hash map is before
Yeah, you don't want to push it. Don't be blatant.
before we try to produce an answer. So
Subtle.
we've got -2 saying that there's a 1 in the array, and we've got -2 saying that there's a 0, 1, 2, 3, 0, 1.
And also be respectful, like
Oh no, 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 no.
make a little note. Thank you very much for what you've done.
This just needs to be not equal to -2.
If you listen,
Okay.
you
Alright.
start to pick up
Let's check all the test cases.
of repetitive, the same chord progression over and over and over again.
Okay, we're back to green.
Within the same artist all the time.
Let's go. Not a clue if anyone's watching, but I just struggled for a while on this problem called first missing positive, and I came to a solution, so I'm really happy about that.
If you have a lot of different chord progressions in your mind and you know that, you know what, if I do this, I do
Also, let
this,
me pass this song.
it'll sound new.
Okay, so to review, the solution to the problem is to treat the input array as a hash map, and the hash map, or just as a map, and the state of the map indicates whether or not integers exist in the input array. And then, okay, my brain is actually getting frizzled out now, so here's the code. Okay, let's just look at the explanation, because they can probably explain it better than me. First of all, let's get rid of negative numbers and zeros since there's no need for them. One could get rid of all the numbers larger than n as well, since the first missing positive is for sure smaller or equal to n+1. Okay, so we did actually figure that out. We start off with our answer being n+1, and then if we don't find a better answer, that's what gets returned. And the reason for that is if you have 10 elements in the array, let's just assume that those elements are the integers 1 through 10, then the answer would be 11, right? It can't be anything higher than 11. It has to be either 11 or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we figured that out. What does it mean to get rid of if one has to keep O in time complexity? So yeah, one could not pop unwanted elements out. Let's just replace them all by ones. Yeah, that works too. So the scheme that you use to flag stuff in the map is kind of up to you. For me, -1 means that it was originally a negative number, and -2 means that -2 means that we're flagging that index to say that the integer that it represents is in the input array. And I didn't do anything special with 0, I just left it as 0. So now we have an array which contains positive numbers. Find the first missing positive in constant space and time. That would be simple if one could be allowed to have a hash map, right? But you're not allowed to have that, so so use the index in nums as a hash key and sign of the element as a hash value. Yeah. That's kind of what we did. Let's just look at the code. Okay, so they have a simple base case here, which isn't super necessary. But if you just want to run through the array right at the beginning and discover before you even do anything else that it doesn't have a 1 in it, you can do that. So you can just detect the absence of a 1 and then you just return 1. So then the next thing they do, this loop right here, is basically my for loop right here. Except I replace everything with negative 1s, they replace everything with 1s, that's fine. Oh, I actually, okay, so the base case is actually necessary because after they discover that there's no 1s, then they can just return that 1 is the answer. But if they know that there's at least 1, if they know that there's at least a single 1, then that kind of just, it makes it so that it's safe to put 1s anywhere else, is the idea here. So you know that there's at least 1, so then you go through all the shit that you don't care about, which is the numbers greater than n and the numbers less than or equal to 0, and you just make those 1s for now. Oh, interesting. Okay, so this is slightly different from what I did. So yeah, instead of swapping the number, you can just make the number negative and use that as an indicator that that the index of the number, like the number represented by that, is in the input array. And so that's why they first have to take the absolute value of the number at a specific index. Now the index of the first positive number is equal to the first missing positive, so then they have their final loop to generate an answer. I have that here. And yeah, then they just have, you know, so yeah, a couple of other cases. Linear complexity, constant space. I have that as well. My running time is fine. Let's run it a few more times just to see if that changes at all. Okay. Yeah. So as you can see, like the timing is not very consistent, but I'm ranging from like 180 to 300 milliseconds. And the best one I had, I'm faster than 85% and 77%. So back to the solution. So I was just looking at this right here. This, another O of n solution using the cycle sort. That's pretty similar to how I ended up solving it. So instead of using a negative number to indicate the presence of the number corresponding to the index, you can just cycle the numbers around and you end up having to use a while loop. You can see while I is less than n, while I is less than n, and then they have a case where they switch numbers around, and then they have a case where they just increment by 1 to move forward. Oh, and then, okay, yeah, this is way more similar to my solution, because if you look at this, that's exactly what I'm doing. So if I find a small positive that's missing, I return I plus 1, which is what they return I plus 1, which is what I'm doing. Otherwise, return n plus 1, which is, I have n plus 1 up here. So, I mean, I could rewrite these lines of code the same way they did it, and it would literally be identical. So this would literally be return I plus 1, and then this would be return n plus 1. And then you can see, like, it's effectively the same solution. I submit that again. Assuming I don't mess something dumb up? What? okay, wait, it's not the same because I actually iterate backwards through the array. All right, I can iterate frontwards through the array. This is probably better anyway. I is less than n plus plus I. And so basically the first one I find is the answer. I don't know why I wrote it the way that I did. I had written it so that the last one I find is the answer. And this is just return n plus 1. And then that enables me to get rid of this. There we go. So it's not going to speed it up or anything, but I just kind of wanted to show that the cycle sort solution, that's effectively what I'm doing. Maybe in a slightly more convoluted way than theirs, which is very pretty. And then at the end, you just iterate through all the numbers. If you find one that's missing, you return I plus 1. Otherwise, you return n plus 1. I just want to look at a couple of other comments here. Solution with a string of length n. I don't know what they're arguing about, but since I'm already at the second comment and people are arguing, I'm not going to look at that. Whew. Okay, that was frustrating at times. We came up with a solution to problem 41, first missing positive. I did attempt this problem. If you look at the dates here, I attempted it 3 times back in 2020. Did not get a solution. And so I tried it again today, July 19th of 2022. As you can see, I did struggle. Runtime error, bunch of wrong answers. Stupid wrong answer here. That was just because I was being dumb. But we did end up coming to a solution that works. It uses a cycle sort, which is a valid way to solve it in linear time. And okay, so just going back to my profile real quick. First missing positive. Yeah, so the ones we solved today, I started on find winner on a tic-tac-toe game. So we solved that pretty quick, pretty easy. Valid word abbreviation, we solved that pretty quick, pretty easy. Shortest word distance, that ended up being a 2 pointers algorithm. A little bit more challenging, but we did get it. Shortest word distance 2 we got, it was just a slight variation on the first one. Then I started my LeetCode dynamic programming study plan, and I made the mistake of starting on level 1. It's probably going to end up being fine because I looked ahead to the problems for tomorrow and they look more interesting. But just in order to finish day 1 of it, I had to implement Fibonacci number and nth Tribonacci number, which are simple dynamic programming. Kill process was a graph-based. It was a tree where basically if you delete a node in the tree, how many elements are in the subtree rooted at that node is more or less what you had to do there. Ended up being fairly straightforward. Then we found the shortest path through the binary matrix. Where's my code? Which was also a breadth first search using a queue. Then we solved first missing positive, which is the one I was just looking at. It's a really, first missing positive, it's annoying. Definitely annoying. However, I think it's valuable because it kind of like forces you to realize that sometimes you have to look at a problem in a slightly different way. You know what I mean? Let's go back to it. And it's because of these constraints they give you right here. Implement an algorithm that runs in linear time and uses constant extra space. And the reason that that makes the problem significantly more difficult is because the linear time algorithm is straightforward if and only if you're allowed to allocate and use your own hash map like on the side to like keep track of where shit is. keep track of like which numbers you found. Since you're not allowed to do that, you're forced to use the input array as the map that you need. So instead of allocating your own map, you use the input array and you like rewrite values in it in a you know, an intelligent way, so that you're not also deleting information that you also need. So it's kind of cool. I think like the moral of the story is, I don't know what the moral of the story is, but just looking at problems a slightly different way, kind of like taking a step back, turning your head to the side and being like, oh, you have to use the input array as a hash map without deleting important information that you need to solve the problem. So that's where this mess comes in, and it solves it. There is so this solution is what I came up with. It is accepted and it does have a good runtime. But if you go ahead and look at the solution page, what they have is prettier to look at for sure, and it's got like comments and stuff. And then if you scroll down and you look at the cycle sort algorithm, this is pretty much the same thing I did, but again, a little bit easier to read, and it's written in Python. So if anyone's still here, thank you for watching. This problem here is called Basic Calculator number 3. I'm gonna do another stream like this tomorrow because I'm preparing for technical interviews. And so I'll come back and I'll definitely solve this one because I think it's interesting. And then after that, I'll just poke around and see what else. You know, I'll keep looking at LeetCode and look at other problems and stuff that will be interesting to solve. But that is going to wrap it up for the stream for today. If anyone's still here, thanks for chilling out. I did get some follows today. I got 4 new follows, so very happy about that. Thank you very much. I'm going to be back again tomorrow with a similar stream, so keep an eye out if you're interested in continuing to go down the LeetCode interview prep journey with me. I hope that if you were here that you learned something. And yeah, that's it for the stream. So I'm going to needlessly switch to a stream ending screen for, I don't know, a couple of minutes just because I did make it. And then the stream will be over for the day. So anyone who's here, thanks for watching. Please come back again and have a great evening. Good luck with your own coding challenges if you're doing them. Peace. Have a good night.